analysis that we did and also extracted parameters from it to be able to input them into our project. So taking it into account, we did this two first optimization processes where we moved some points over our site with the rules of maximizing floor area and building volume and minimizing radiation. Then in the second one, we also included the circulation analysis that we did with PetSim to the optimization. So we were having two separated mass as we saw with the analysis. However, these methods weren't very controllable. So we went for a third optimization process. In this one, we started with the circulation analysis as the basis, which is rotated and offset to create a space in between the two masses in all the 5 floors that we have. So in this optimization process, we had to include the rule of maximizing the area of the lower public space between the two buildings. These are some of the results that we got, and that one is the one that we selected as it was above average in all the fitness values that we set. And this is how our mass looks like, which, as you can see, we could have a match control design algorithm, and the circulation analysis is really affecting the space in the two buildings, not as at the beginning. After the massing, we did some structural studies. We started by doing an inner principal structure with columns and a core inside, but we wanted to have a free and flexible interior space. So we tried to have only an outer structure. We studied how it will be with just an outer structural quad grid, but it had a lot of utilization and a huge mass. So then we studied with a triangular grid, only outer grid, but it still had high utilization. So we had to combine them with a triangular grid and some columns on the inside. After these studies, we saw that we had a very disproportional material distribution on the facade, as you can see, with some elements which weren't used at all and others which were with a high stress. So we decided to optimize the cross-section of the triangular facade grid depending on the utilization and the stress. And we have beams that go from 5 to 15 centimeters. As you can see, to test different stability systems for the cantilevers, we included a core in building A, but we just used 2 columns and the facade grid in building B, which has bigger mean values of utilization, displacement, and stresses on the facade as a consequence of that.
So this is the site plan and our plans. We have a circulation in the middle. So program public area for ground floor and the first floor. Then third floors are for office at the building A, and the classrooms for culture and language sharing at the building B. So, so our question was how to combine all of our studied data. So in the end, we have 3 panels that depends on the our analysis. So this is the reference for the our panels and plant, and then rectangle, triangle structure with the window. So this is the extruder panel for plants. For the facade design, we divided the five floors by 60% and 40% for public and private area. Then divided again this value for openings. So we gave same 20% openings for offices, which is quite private on building A, and classes rooms, which is semi-public space. And building B is more close to public, so that we gave 50% of division of the total floor. And our second proposition for the facade design is that we gave 60% and for offer 3 floors for both buildings, then increase openings value. In the result, compared to this first proposition, 67 square meter for the building A and 140 square meters for the building B are increased. Yeah. So after made our proposition for clients, we thought about how could we decide a better design. For us, daylight availability study was the decision maker for it by predicting the interior thermal comfort for users. The red color represented the zone of over 50% occupied hours by daylight autonomy at the test of annual sunlight exposure. The first proposition area is better because it means the purple color means represent us that there is a less potential area for glare or overheating by daylight. So this is our our facade design. So proposition 1 was like less windows, and then we have a circulation, and then this is building A. So people can circulate by our path of the middle. So this, since these slabs and structures are wood, 2 buildings has a long lifespan by changing a part of its structure or changing facade of openings or panels. So this is the elevation. In conclusion, the form finding process with algorithmic problem solving tool showed us many of particular mass configuration. We learned that before start optimization, we should have our own rules or strategy for concept instead of expecting cool design without criteria. For the detail of So yeah, this is the end.
Thank you.
Great, thank you guys. We can have the next, oh, you're getting so many claps. We can have the next group now, and you will be back with us for, well, you will still be here, but you will receive comments and feedback after the 3 groups.
Yeah, thank you.
Can you see my screen?
Yeah, perfectly.
Okay, cool. So we are group number 5, and the name of our project is Widok, which means view in Polish, and which is kind of like the main concept that we have for our project. So the presentation is divided in 5 sections. So the 3 first sections are related to the manifesto and the urban analysis. And then section number 4 and 5 is related to the computational design process. So in terms of the manifesto, we start looking at what is the implication of the historical ledger in Krakow. and how to establish new connections to improve the quality of urban spaces and enhance urban activation, which is kind of like a mix of the urban domain and the public domain and the architecture. We want to generate a new elevated pedestrian framework and define new relationships between the existing historic buildings and the landscape in Krakow. So our site is located in Krakow. It's next to the Vistula River and next to the historic center in Krakow. And then, as you can see, the site has a significant amount of trees, but then it lacks from street activation and different uses. In terms of the site analysis, we start looking at a general overview of the environmental performance in Krakow. So we have all the dry bulb temperature, relative humidity, and all the wind and speed and directions that inform our design. We also start looking at the surrounding of our context in relationship to our site, and we identify all the historic places in Krakow. And then, as you can see, the site is located next to a river. It has a direct access from the river, and as well is like facing two historic buildings in the city. So for the urban analysis, we use Grasshopper and Elk component where we manipulate OpenStreet data, and basically we start looking at the different urban systems. So we have like the public transport. We start looking at the different connections of the public domain to our site. So the main key plazas surrounding the historic city center, and then also related to our site. So in terms of our relationship to the green and the blue network, so we start looking at the new character of our site inside that structure. So then that took us to the definition of all the open spaces, and we start looking at the different uses of the blue infrastructure as well, and what was the relationship and the implication of those open spaces to our site and how they could inform our decisions. So based on that, we identified three main issues, which is the lack of urban activities in the open space, disconnection of the existing green systems, and a lack of a relationship between history and heritage places. So based on that, we want to define three design principles that relates all cultural activities with history and the city and also people. In terms of a space program, we have defined a cultural type of uses where we start looking at a different vertical and horizontal distribution of them, and as well as how we can start having different levels of distribution. So we want people to access, interact, display, and observe in our structure. And that's kind of like what is driving our design goals. So in terms of the steps, we have 5 steps that informs our decision making, and we are focused on the definition of all the systems.
Yeah, so now talking about our computational design process, our goal was to fit our geometry in between the existing trees. So first we identify our plot, then we identify location of trees, and we define a hexagonal grid that then we pack circles inside it. And then for each level, we'll have 2 circles. And for the ground floor, we'll have 1 circle to minimize the impact on the ground. And then we start connecting them vertically. And then we introduce minimal surfaces in Kangaroo using soap bubble. So our geometry will be based on minimal surfaces. And you can see the comparison between the low poly geometry and the minimal surfaces mesh. And the React mesh. And we look at our structural performance in Karamba. And so first we took our massing geometry and we meshed it to be composed of the linear elements, and we use steel beams spaced at around 1 meter. And we'll be using steel sections ranging from 20 to 30 centimeter deep. And using minimal surfaces, we take advantage of them, the surface being continuous. And we also want to revolve our geometry around central axis to provide stability. And for structural analysis, we took into account gravity loads and wind loads from both directions. And we first look at the one module, and we identified the problem that the one standalone module will have quite significant horizontal and vertical displacement, as well as high utilization. So then we started clustering the modules so that the platforms can be joined at each level. And then we analyzed this clustered geometry, and we looked at it performed better in both in terms of utilization, but also we minimized the deflections due to wind. And now the highest deflection occur at the top floor due to gravity and wind. And we tested different clustering options, from which we came to the conclusion about the height of the standalone towers. So in conclusion, we said that only one height of the platform cannot be joined with the neighboring ones, because a single 4-level tower is not performing well. And this is why we start clustering our models. And then we look at the environmental performance of the structure. And we looked at the annual sun analysis. Our goal was to maximize the sun exposure for each platform. And in here, we show the sun location in December and in June, so in the longest and the shortest day. And our goal was to identify what angle orientation of the module was the best, so that we don't have a lot of self-shading. And we identify this both for one module and then for clustering. And the result from this analysis gave us a range of angles that will inform our next optimization steps.
So next we started to set up our optimization process. So here in the diagram, we can see our site is surrounded with the most important historical nodes. And the main goal was to increase the visual angles from our site to these nodes. And in that slide, we can see our optimization process that was done inside Wallasey. So in the first diagram, the colored lines are the view range, and the black lines are the block views from our site based on the collision between surrounding buildings and trees. And on the right diagram, we can see our platforms are trying to be changing in height and orientation. So basically, they were changing based on many variables, which are the platforms level and platforms orientation, different views and view angles, and levels limitation to decide how many towers we can have, for instance, for 5 or 10 or 15 meters. And all of that optimization was done to have 3 goals. So first, we wanted to minimize the angle between the platforms and view nodes around the site. And second goal was to increase the view range of our site to historical nodes and to minimize the blocked views lines. And the last diagram is the graphs coming from Wallasey, which is here we can see the 3 goals, and basically Wallasey trying to deviate the graphs more to the left side to have a better performing actions based on these parameters. In the next slide, we have a lot of iterations coming from the optimization process, and we wanted to focus on the most 3 performing iterations. And we chose the most, the one with the most directing platforms to different nodes. Then we started to generate our manual services based on that iteration. Then we started to look at the details for one module, one vertical module. So first, we wanted to have a nice quad mesh coming from that geometry. And then using developer strips principles, we wanted to have a continuous strips coming from horizontal to vertical directions to perform better in structure performance. And then we have different views or different angles of views for tower, shows how people interact with the structure. And then a plan view shows what is the interior circulation that people can use to go up for different levels. And we can see another sectional view that shows the connection between horizontal and vertical elements and stairs and what are different activities that people are doing inside the structure. And for the architectural quality, first we went back to the whole model to generate the same details on our old platforms. So first we have again our triangulated mesh, and using again developer strips principles, we converted these meshes into smooth continuous lines coming from horizontal slabs to vertical cores of better performance. And the next diagram shows what are the difference, or how many strips do we have. So basically in the color map, we have different strips based on different colors and different black boundaries, which can be later fabricated and assembled. And another diagram for the floor plan, which shows what are the main activities that people can do inside the structure, and again section with different activities. So people can actually drink coffee, view things, draw, exhibit, do yoga, and things. And finally, we have our render shots for the final geometry that shows how people interacting with our structure in different levels, and how the structure is growing in between trees, and how people interacting in different levels. And next shot shows what are the distance between nature and our geometry. And the next render shot shows the interaction between people in different levels. So basically they can like interact with each other in different activities. And another render shot. And another render shot shows the elevation and what are the heights for our structure, and basically what are the relationship from the street view between our structure and nature. And another written shot shows how people can access our site from street level or from the park level from behind, that they can move smoothly from ground to top levels. And last render shot. Thank you.
Thank you, guys. So one more group, and then we can have some discussion.
Okay, makes sense. Can you see the screen?
Yes, great backgrounds. Great team backgrounds, everyone as well.
I said we started selling t-shirts now. So welcome everybody, good afternoon for the ones in a different time zone. This is the final presentation for the studio assignment called Ubuntu, that is about creating cultural connections on a segregated city. Group number 3 consists of Andrei Okolukalak, Roman Bodenbender, and Sergei Krichkov. And we name a thesis Ubuntu that is about creating new urban connections. Ubuntu is a Zulu word from an Ngubani Bantu term meaning humanity, and it's often translated as I am because we are. We completely embrace this term on the design and development of a bridge and understanding how individual elements can work collectively towards a goal. This is the table of contents that goes all the way from the manifesto and our beliefs till how we arrive to the final shape. Now we'll pass it to my colleague Sergio, that is going to talk about the manifesto.
Hi, everyone. The modern city belongs to vehicles. Pedestrians once have occupied the city, and it has been actually built by the pedestrians and for pedestrians, but the times have changed. We are keen to deliver the design that should address the fully accessible and safe and friendly pedestrian environment to connect neighborhoods, so that the entire city becomes our living room. Our design objectives are to use the sustainable materials, prefabricated systems, and to make the whole structure disassemble and be repurposed when time comes. Our site is located in Johannesburg, which is South Africa, which is the iconic separated city due to the policy of apartheid, which was on in South Africa for over 50 years and had huge urban design impact. Johannesburg has been originally designed in order to segregate the different races, skin colors, and social strata, and prevent any interaction and communication. And that's what we want to address and change. And now I would like to pass it to Andrei, who would tell about the site.
Hey everyone, so we've done several site analysis, and we realized that the site that we're working with has hardly any green area. And instead, what it is, it's an open field of rails. And we've done some environmental analysis that you can see in the next slide. The temperature is relatively comfortable all year round, and there's little wind that's coming from the north just a few winter months of the year. On the next slide, you will see that the more important factor, environmental factor in our design is the solar radiation. And as you can see, if you're exposed to the sun and wind, it's not the best, most comfortable time. So to conclude with that, we'll be focusing on radiation and wind in our analysis, in our design, sorry. We've done further urban analysis for our sites, and what we realized is that around this field of rails, there are many attraction points that attract thousands of people. But what we're working with is separated, isolated neighborhoods without a particular strong interconnection. Universities, museums, and shopping malls are all there and attract many people, but yet they are isolated. And that's a problem for the city's attempts to counter the urban decay. So in the next slide, you will see the only two possible ways to cross this field of rails right now, and these are the two existing bridges. The bridges were initially made for the cars, and as you can see, the pedestrian experience is not very positive, which is what also these bridges happen to be two of the highest crime-filled spots in South Africa. I will now pass it on to Germán to talk about program research.
So from the conclusion from this analysis, we then understood that we need to create a connection in order to move all the density around, and also to bridge the segregation that the railway infrastructure creates. We then recognize two sites, site A at the north and site B at the south. Site A, that is an abandoned triangulated site parcel that is connected to the urban fabric, and then site B, that is on the south side, is an underdeveloped urban park currently underutilized. Then we understood that we want to create a vector connection between A and B. We want to be able to provide the shortest travel distance between these two in order to move the density of people around it. But also, we want to create a meaningful experience along it. That's why we decided to develop a program and host that program into the bridge. We also want this program to be not just at the beginning and at the end, but also in with it. We also want this bridge and this connection to become a cultural ambassador of African art. That's why we identified the 6 more prominent art type of currents currently on the scenario of the art scene in Africa. We then started a design process. And we started understanding and recognizing the two sites we want to connect, and we also understanding what is the barrier that sits between them. In this case, a 75-year-old railway infrastructure that is going to be here around for another 50 years. We then recognize the interstitial voids that are between the two connections and the possible areas that we can use to place a support that we're later going to use for optimization. We then select and recognize all the sites, and we cast a grid of point that is the one we're going to use for the optimization algorithm. This gives us a density and a total count of points of more than 6,000 points. We then did a very first attempt to create a path connection between them. So we did a very first selection of points, one from each side, and this gives us this very first meander that connects A to B. We then fit this line principle into a genetic optimization algorithm that consists of 4 different goals. The very first goal is trying to measure and reduce as much as we can the travel distance between the 2 points. The second and third one measure both slope of entry and exit of the bridge in order to create a wheelchair and pedestrian-friendly approach. And then a fourth goal, measure radiation in order to try to reduce the amount of sand that this bridge exposed in order to create a more comfortable experience as we walk through it. After a series of multiple iterations, we arrived to a final decision. This is the one you can see on the screen. This gave us the shortest travel distance of 422 meters that is based on the shortest possible scenario and also to avoid the buildings on the sides. Also, we managed to arrive to a slope that is less than 8%, and this is the one that presents also the least amount of radiation because the shortest term and the least amount of curves. Then we did a quick verification of elevation and slope, and as you can see, we achieved the desirable result of having a bridge that elevates less than 11 meters and a slope of 8%. After we got an optimized path, we started doing a module research, and then we plot the principles. And as coming from a manifesto, we want to develop a single module that can adapt to all the circumstances, that can also be prefabricated offsite out of wood. So we want this module to be able to then protect us from the weather, what is necessary, also to be able to open himself to the visual extent, also at the bottom to be able to protect us from the noise coming from the railway, and also, as you can see on the left side, be able to grow wide or narrow when the space requires. So then when we started the construction of this module, we fall into the most structural system that is a triangle. So we start with a triangle on the 0, 1, and we start stacking this triangle along the optimus path. Then in scenario 0, 2, we create a parametric relationship that allows us to grow a leg when it's required in order for the bridge to touch the ground. Then on 0, 3, we also create a second parametric relationship that allows us to grow the module wider or narrow on the areas we want to host program. Then between 0, 4 and 0, 5, we further create a triangulation that not just give us a better structural support, but also help us to create the railings, the screens, and the necessary roof on the areas we require. We then took this module and we plotted along the optimus path. And then we did a series of further optimization. Here we use a series of attractor points that help us to identify the areas we need support and then grow a leg in order for the bridge to touch ground. Then on the second series of attractor points, we then use them to place the program on the areas we need it. So as you can see here, this is the areas where the bridge becomes wider and help us to host a better program. After we grow the bridge wider, then we plot the program into the sites. We create 6 different types of experience from 1 to 6, 1 being the one on the north, that is when the building touches the ground and becomes a space and a building. And then all the way between 2, 3, 4, and 5, we have a cultural experience, also different type of arts along the path. And then when we get to 6 is when the bridge touches the city and becomes a park again. And then now we'll pass it to my colleague Andrea that is going to talk about the structural analysis.
So the hard lesson that we all learned is that it's always fun to design bridges until you have to structurally analyze them. But our strategy to analyze it was to focus on smaller sections of the bridge and to use the deformation rates to see the global issues and utilization to search for stress on smaller elements. In the next slide, you will see that the first global issue that we faced is that our floor sinks down, and an easy fix for that was placing columns along the bridge. In the next slide, you'll see that once we placed columns, it still wasn't enough, and the bridge part between the legs keeps on sinking. We fixed that by adding a truss. And in the next slide, you will see the many iterations that we've made where we modified elements, subtracted, added, changed the cross-section thickness to come up with a module that works with us. And we came up with a wooden model that is applicable to the whole bridge that is visible in the following slide. And I will now pass it back to Germán to talk about skin optimization.
So after we optimize structurally and we have a sound structural system, we then started looking into the environmental factors and how this bridge can protect us from it. So what we did is, based on the areas we want to host program, that is on the areas where we grow a leg, as you can see on the top, we want to be able to develop a parametric scheme that allows us to protect us from the sun elements on certain areas, but also be able to open himself towards abuse as well, without neglecting the pedestrians from the city. So as you can see on the bottom left, on image 01, we developed a rectangular scheme that actually is compounded of 4 different triangles, and the triangles open himself, as you can see on the image 02, towards the view side, that is the southwest. And then it closes himself toward the angles where the strongest sun comes, that is the 03, that in this case is the northwest scenario. We then need further analysis, both radiation and comfort, to see how a space performs without the skin on the areas we want the skin. And as I said before, this is not to enhance and protect the entire bridge, but just on the areas we want to host particular type of program. And I'll pass into my colleague Sergio, who's going to talk about materiality, technical documentation.
Having shaped the bridge, we started addressing its materiality and detailing and joints and how it actually can be built of timber. So we have drafted it out accurately and dimensioned it, and here you can see that it performs as a spatial beam or tube, and the supports are cones, all assembled into a mesh from standard glue lamp bar of standard sizes, from 100 by 100 to 250 by 250 millimeters. And they would be joined mostly with a star-shaped metal connection, because the bridge turns all the time, that you can see on the next slide. There are 2 types of star connection on the left, and then the basic module, which is flat, will have its members connected with a flat steel plate, and in the bottom, the wooden elements are attached to the concrete foundation with a steel plate with a rigid bracket. And now I'm passing it back to Arman, who will show some final renderings and the look and feel of the bridge.
So after this process, when we arrive to the final prototype, and this is a journey that goes from south to north in the way that people will approach it, walking towards the university. So as you can see here, this south park where the bridge grows from the park and invite people to start taking the journey up. And as you can see, this becomes the very first sculptural park that takes the people up. Then now walking towards the bridge, we got our very first area of the bridge of the host program. And this is now what we started growing this skin that protects us. And as you can see how now the skin is the one absorbing the most amount of sun radiation from it. And this is now the image from below to see how the skin actually protects and casts these beautiful kind of African pattern shadows underneath. And as you can see here, how the skin looking, this is the image looking north, how it closes himself, creating the shadows. And this is on the very same part of the bridge looking south. And how different time of the day is, how it protects us from the sun, creating the shadows, but also still open himself to connect the people towards the views of the city. Now keep walking towards north, and now we're starting seeing the bridge started going down to connect back to the city on this particular area. And this is now when we grow back a leg, and then now the building also be able to host programs underneath in order to create secure and movement of people as well. And this is now finally now rise to the north destination after a meaningful and cultural trip where people take it from the city. And this is now kind of a conceptual view highlighting it, how the materiality and everything will come together. Thank you very much.
Thank you.
Thank you.
Thank you, all the three groups. So now we can have some comments from the jury, some feedback.
Should I jump in then?
Sure, Arthur.
Cool. Well, congratulations, everyone. Impressive work, especially knowing you're all working from home. It's pretty good. I guess I took a few notes, and I'll probably start from Kim's group, then Felipe's, then Herman's. And it's nice to see you guys do other work than in the studio that you're in with me. Kim, sorry, I only saw Kim, but it's your whole group is probably here. I think in terms of I have a few points on your presentation, the computational process, the context and materials. Presentation, I wish you'd start, and maybe that's for all of you guys, because your process is so important in this kind of approach. It'd be good to start with the bigger vision. Either it's a big title or one sentence that summarizes why you're doing it, because it feels like it's so many plugins and grasshopper operation to get this system in place, which is fantastic. But that in itself is also a vision, right? Like the idea of creating a fully bottom-up architecture that emerges from so many parameters. I would love for you to explain why you're doing that initially. It would be good to know how the process even works. Like I saw you did some decibel analysis, and I wonder how you get that result. Like whenever I see analysis, I'm curious to know what was the way it's happened, not just the conclusion is what I'm trying to say. And I think there's something that's really kind of missing. I feel, maybe I'm wrong, but it's the materials, like what sort of materials you're using and how does this inform the size of your triangles? Is this material environmental as well? Like, can you vary the depth, because it's pretty much those volumes and then the skin. And then context, of course, like it stands out as something that might not relate too much to the actual cultural context. So I think a few images of the site and bringing us back to the city, I think it was in Madrid, or it would have been good to feel that, because otherwise it becomes very generic. On Felipe Hesham's group, I think it's similar to the first comment about saying why why you're doing the things you're doing. You start with saying, "Oh, we have a manifesto," but I think it's better to actually just say what it is rather than give us a heads up on having a manifesto. It's a little thing, but I think it has its weight. I'm curious. I mean, the geometry is beautiful. It's really stunning. But I'm curious why the soft form. Why because when you see these topological kind of columns, slight and then curved and stuff, it's very important to I think, and maybe I missed it, but why is it soft and curved? You know, is it for structural performance?
Yeah, I think, should we
Go for
reply
it.
now?
Yeah. Please.
Yeah, I think we explained that in maybe, explained in structure performing, and we were saying that we are generating on linear surfaces to have like a smoothly continuous structure performing from the horizontal slabs to the vertical cores and the ground.
But why?
So then we...
Is it structural? Is it for wind? Is it...
Yeah, it's structural, right. To have like a better distribution of forces, through all of these directions to the
better
ground.
Distribution of forces.
Yeah.
Right. Okay.
And I think we had that diagram that shows like the transition. I'm not sure if we have to present it again or not.
No, that's cool. Don't worry. I think I'm just putting my thoughts, so maybe maybe I'm missing stuff. It's true. I think it's always good to do comparative analysis though. Like, how would it be before you pressed subdivide, or before you start minimizing, to compare this with the more faceted straight version? I say this because not everything necessarily would benefit from having this system in a straight way, and the straight version might be, sometimes more, especially because you're putting staircases that are straight anyways. So I'm quite curious to see how the curvature is informing the spaces, the strips, the fact of doing strips. I was confused because in terms of materials, like I'd imagine the strips are done because you'd want to extract them for fabrication, but then I see concrete as a material used in your renders. I guess I'm curious to see if the fact that you're extracting strips is related to the fabrication process, or if it can inform your internal architecture. And I guess, sorry, I'll finish with Herman. There's so many things to say and so many groups. I really enjoyed the page where you had all your criteria for your bridge and the triangles, and it's a shame. I think this is something to really work on. It's a shame that the text was like just a placeholder. But it was a good page. That's what I meant by explaining the whys. Like, I think you guys have made a good job by saying the triangle for structural, the positioning and stuff. But in terms of the curvature itself, since it's one giant NURBS curve, it'd be nice to see a tiny bit more control over the making of that curve. I don't know if you know about like G1, G2 continuity on a curve and alignment of control points, and so it looks a little bit like it's not necessarily aligned with elements. Because I guess the genetic algorithm is letting it do its thing. It would be good to understand, or maybe visualize, the control points at the same time of this being made. In the skin itself, it's a lot of members, and the column seems to be misaligned with the language of the triangle. I feel like it doesn't. I feel like that the triangles themselves should become the column somehow. And so I appreciated when you simplified it in your renders, where it seems like there's a little bit less elements. But I'm confused between the relationship of the space, the width, and the program that you're using inside. Anyways, that's all for me. Sorry, that was a long one.
Just to answer to Arthur, we actually 10 minutes is quite short, but we very first 2 pages we explained about why we had a immigrant population stuff. Like, we explained why we did it, and then also material. And we didn't really specify the material because our focus was to why and how our facade design was born. But we gave also explanation of a dimension of a triangle. There was a page, but it was really short. I had to pass really fast, so that was the reason.
It's good. It's a good challenge, 10 minutes. It's good training.
Yeah, but architects never
I never manage, I know.
So, Carlos, do you want to go next, or should I try?
Carlos.
Sure, man. No worries. Yeah, I have like some comments. First of all, congratulations, guys. Looks like lots of work that you guys have been developing over the last months. And I mean, it's the first time that I've seen you in action. So I'm kind of happy to see all this analysis working just to deliver such amazing geometries. I think like in general, all the projects you guys have like very good intentions, and you started to work in a very intense focus on sustainability and structural optimization. I'm just thinking that I'm gonna go one by one because I was taking notes of all the three projects, so I can just give you like some comments on each one of you. I mean, for the first one, for the Public Culture Center, I'm thinking that because since the point of view that you guys did a building like itself with like it's containing like a program for having people inside, it's different from the other ones that they are structures. And I was missing like a little bit of energy. So I think like the three of you guys think, I mean, you are talking about sustainability, but you don't talk about energy. And so especially when you're talking about the building, the consumptions and the body carbon and the energy use is quite important to estimate it if you want to deliver a sustainable option. So I'm thinking that I will miss like, but I think that you could add something like that in the future, or just have it in mind for future projects that you guys develop. But energy consumption is quite important if you want to deliver something that is sustainable and efficient. So I think it's quite good that you guys did optimization and you put together all these incredible tools to run like, try to find the most efficient kind of system to reduce heat gain and maximize the space inside. And I'm happy that you put together also like all this mediation but I feel like I was missing a little bit of information about the materials, as Alfred was saying. I feel like when you talk about energy consumptions, you also need to talk about how much energy your building is consuming from the perspective of your materials. So if you don't talk about why you choose your materials and what are the implications of having sustainable materials, I think you're missing like an important thing there. I think like a good suggestion would be like guys focus on looking at the sustainability standards, because like nowadays in architectural practices, all of them are looking at architectural standards. Sustainability standards like LEED, BREEAM, NAVERS. I think like there are several options that are international. Others are more local, depending on where you are like working. If you're working in Spain, look at the I think there's one called the Greens assessment from it's kind of like a Spanish LEED version of it, and it has like a quite very nice structure that you can follow, and then you can have all the steps, and basically your analysis basically need to service these standards because they set up the goals. So check it out. I think that would be good. Jumping to the other project, the WIDOP team. I mean, it's very good that you guys work on views and view analysis, and I like the fact that you start to do all this optimization. And just kind of like, from the same point of view that Alfred said, like, why did you guys choose strips when you're showing concrete at the end of the day? I think that there's not a clear justification. Why did you choose concrete as a very unsustainable material? So because of the way it's produced and lots of embodied carbon and energy in the process of consuming. So we suggest that material research should have like an important component on studying what are the implications of choosing these materials. Why it's important? Why are you making something? I mean, did you study, for example, the recyclability or the life cycle? That's something that's very important in the sustainability conversation, to understand what's going to happen once you're going to dispose or you're going to dismantle this building. I think none of you guys talk about what's going to happen in that sense. So, and that's a very, very important key point on sustainability, like to understand like this kind of cradle to cradle concept. So what happens when the material starts, the raw materials, where they're coming from, and where they are going when you are like basically just destroying this building for just, having something else in the future. Because we need to think that all the buildings have a limited life. And I feel since we are talking about the structures, it makes a little bit of this kind of concept of what's going to happen, how you're recycling the structures, how are you going to thinking on reusing the structures in the future. So I think I like the fact that you also use optimization, but I don't see in the optimization process why it's important optimizations from the point of view of a structure. I haven't seen anybody talking about reduction of weight in the buildings. So I feel like that's something that is very important. If you're talking about sustainable structures, reduction of weight is a key point. So at least I didn't see like people doing emphasis on that topic if you thought about it at the beginning. So I like the fact that you put together analysis, and I think the three of you guys, the three teams, work a lot on environmental analysis and climate. But I miss a little bit of other, to go in depth a little bit on this analysis, and I feel Angelos will be like seeking some winner analysis somewhere here that you guys. It's a very important type of analysis that will influence the structural behavior and everything. But definitely, Angelos, that's your topic. I'm very new to that thing of the wind flows. But I feel it's kind of important to mention all these things. And yeah, I feel like that will be my comment there. I like the fight and the look and all the program that you guys set up there, so it was quite interesting. My third and last comments would go for the Ubuntu team. That's quite interesting the way you apply optimization for making the bridge. I really like the fact that you choose wood, so it's good for the point of view environmental thing. I really like the fact that you guys work a lot on the shading strategies. That's a great thing. I miss a little bit of outdoor comfort studies. I feel like some of the teams like the Public Culture Center, you guys work on the acoustic thing, but I feel that all the teams, you guys should try to structure a little bit your sustainability points. I feel like it's kind of you're kind of putting bits and pieces. You hear about some analysis and you put it in your work, but I feel like when you talk about sustainability strategies, you have to really follow a structure and make it kind of like advertise that thing at the very beginning. So from there, your geometry, if it responds to the sustainability strategy or if it meets all these points, it will help you to convince a jury that has, a specialist. Like when you're talking about competitions, for example, I'm talking about architectural practices like Saha, Foster's, whatever. They really, when they're doing competitions, they develop those briefs, and those briefs basically the geometry responds to all these points like very systematically. So you have to be very careful. And all these structures are looking at the sustainability standards. Like LEED, for example, that is like more or less the widespread one. That's something you guys can look at that thing in the future. But I feel like I really like the fact that in your bridge you are using this, as I said, the shading. The only thing I didn't understood exactly is the integration of greenery inside of the bridge. Does it respond to any kind of thinking on sustainability? It was something arbitrary. I saw that you put the trees in the most shaded area of the bridge, when the trees are like really like become part of the shading strategies in many projects. So I feel like you guys could just look at one thing or the other, but the two of them combined, I'm not sure if you just totally get it on that point. So I was kind of missing a little bit of studies on how the greenery is also, for example, helping to reduce the heat island effect. That's something that happens a lot on tropical places or places with really extreme heats. So I feel like I would just need a little bit of information on that thing, but I feel like you were you have the kind of intuition, but I feel like you like a little bit of putting those bits together. Yeah, for all the teams, I feel like you miss a bit of information about outdoor comfort and indoor comfort in a way that could be a little more structured. I feel like you mentioned certain things like spatial data autonomy and acoustics in case the first team. The second thing, I didn't hear about you guys talking about comfort, and that's basically there's like one chapter on sustainability that is always health and wellness or comfort studies, and they really have a massive impact. Basically, all your analysis that you're doing are going to serve the let's say this point of wellness and health that basically is the comfort levels you're going to have, and this basically interacts with the exterior and the interior. So check it out, guys, because I think that if you follow the sustainability structures, you will get like a better understanding how to classify these things, how to put it together. But I think in general, I really like the fact that you all are using all this type of analysis to emphasize that your structures are kind of following, having a base on a ground on this kind of foundation of sustainability. So, but I think in general, it's like lots of potential on the work that you're doing for commercial companies to really look at that thing and feeling really interested in what you're doing. So just keep it and put it in your portfolio, because that basically is going to open the doors of many options and many opportunities. I'm not here. Yes.
Carlos, you took all my points. Um, especially the one with the trees. Yeah, like I was gonna ask the same thing. I'm gonna add my comments here, but like I'd like some feedback, because I don't wanna just like spit out all the information that I have. So first of all, like in relation to all the projects, I completely agree with what Arthur and Carlos said. Because like materials are like, first of all, like sustainability, like we're talking about sustainability, it's a much bigger concept than environmental design, right? And that's why like the course we are teaching is environmental design and not sustainability, because sustainability is a much bigger and more difficult concept that involves also social and political and other like parameters that we're not going to touch perhaps here at all. But just to maybe answer to Carlos, like they've definitely done, so they've been taught and they've done like CFD simulations and also thermal comfort simulations. I think they're either keeping them for tomorrow,
Exactly.
which I hope is the reason why we don't see them today, or they're running the simulations and they haven't finished yet, which means it's also possible that they will be presented tomorrow. So yeah, I hope we'll see more of that tomorrow. But
both is true.
Both is true. Great to hear that. But when we're talking about sustainability and materials, there's a lot of wood, and there's a lot of like talk about like how wood would be like more sustainable material or whatever. Like, but this is something that it's when you have like a bridge, for example, that has like thousands of like good elements, and we're not really sure how better in terms of like carbon footprint that bridge can be from like, I don't know, a steel bridge or whatever. It's something to be, maybe there's like there needs to be some metrics there, and I think especially embodied energy is something that no one has touched. And it's, I think, a really important aspect. So like, you're talking about materials, but like the embodied energy of materials is really important. And it is possible that you say, if I compare this bridge or like this, because it's been, or this structure with, with concrete, for example, then it's much more sustainable because I've like wasted much less kind of like, carbon to produce it. Of course, it depends how where you source your wood and all of that. So it's a bigger concept. So it's also like important to know, is it locally, available? Is it like sourced locally and all of that? That's also very important, especially in NIAC. Like this is a very important aspect. So generally, when you're talking about your sustainable approach or your like, your optimization, and optimization is a completely different story, which is also a big problem. And in many cases here today, optimization is a little bit like used loosely, because you say we've optimized for a certain parameter, but it isn't very clear if you're taking into account, I don't know, different parameters if your optimization is kind of like very sound. But let's go group by group, and maybe I'd like some feedback if possible, because I don't want to just say things. So first group, there's clearly like there's been some unresolved design. There's like you haven't reached the end, and I think that's clear from your presentation, because it's, I mean, you've done a lot of good work, but it seems that some of it is missing. So if you went one step further, what would you do? If you may answer that, Kim and Jaime. Yeah.
Yeah, a very good question. So, if we work further, we have to test the materials. Actually, our very first objective was to test physically with different materials, because our sustainability was one of our goal. But this is like online course, and then we didn't like a month was not enough. But if we have more time, we have to focus on the how can you construct with the structure and the panels, and then there are a bunch of different panels will be tested with different materials like clay and sands and
that makes sense.
Yeah, and also as we talked last week, we were on doing this energy studies and consumption studies, but due to time we didn't finish them. And
yeah, so maybe this question is a way for you to like, it's a way to help you as well. Say there's some further steps that have been designed in the process, and methodologically they're important. So like you were trying to do an energy simulation of the building, and then therefore somehow validate your assumptions of how this kind of like solar radiation optimization actually optimizes the building for its overall like energy consumption in a way. you talked a lot about daylight and how you've optimized daylight in a way, and you have this triangular like windows and the structure, which is like, you know, triangular structure that like kind of like somehow you control the daylight across the different floors. One thing that's important to talk about in daylight is it's not just like a mere like availability of light, it's also the quality of that light. So if you get like a window that's constantly like, it has like these weird shapes and everything, that, you know, and you get like direct sunlight, then it's a very difficult light to handle. That's why we use somehow like diffused or like some kind of like more kind of like normal distribution of light in the space, because when you have these structures, it's sometimes very difficult to control that light. You know, you get areas with harsh shadows or areas with weird, let's say, light patterns, right? Have you thought about that at all? No. So there's a lot of research that has been done, for example, with a kind of like VR, for virtual reality, and like, you know, and daylight options, and like you could actually look at that in a bit and say, find information how, you know, people really perceive these kinds of different light distributions. But yeah, this is probably my comments. Also, like you talked a little about like your environmental concerns, but there's also some design concerns there. There's been like, so one building almost touches the other building. There's like also kind of like issues of privacy in the buildings. There's also issues of even like feng shui, you know, like if you go to China and you try to do like a building that's like, it has like a harsh angle against another building, you're probably not going to be able to get that through planning, right? Yeah. Anyway, so that's my concern for the first group. Second group, you're talking about optimization a lot. Like, is it just the views that you're optimizing?
Yeah, just the views.
Okay, so you're optimizing the views from your site to other sites, right?
Yeah.
Now this is, it's a little bit tricky in the sense that like, it's a little bit like selfish, your design, if I may say. Like, it's first of all, great work. You've done really a lot, and it's a very sound kind of like.
Of course, the other type of analysis, structural and environmental, just it was directing the design in some way, but the main optimization goal was to maximize the view angles.
But when you say you're maximizing, so you have like these lines of sight, and you're maximizing the view from your site to like important, let's say, landmarks in the city. You're probably also blocking the sight of everybody else around to these landmarks. And that's a very important issue, because I mean, for example, in London, this is part of the planning provisions. You can't really build something, and Carlos would probably know this better, you can't build something that blocks the view to, for example, St. Paul's Cathedral, right? There are some protected views, as we call them, that you can't really build. There is like specific lines, and one of them is actually really interesting because you can go up to like, what is it, like Finsbury Park, and there's like this spot, and then there's like line of sight from Finsbury Park to St. Paul that you can't obstruct. So you essentially cannot build like a skyscraper for half of London, like, you know. So you're doing, you know, the analysis at the opposite way, like what can I see, but you're not really taking into account all these people that will definitely hate you when you build that structure, right? And it's going to be like massive protests, you know, you're destroying my view from the river. So what I'm saying is like it would help you if you kind of like did it both ways, not just what you can see, but what you block from others. Because I also think that if you're just doing an optimization for the view, it's probably not working great, because I would expect just the tower, right? The highest the tower, the biggest the view, and that should be like, you know, the solution. I'm pretty sure you've like somehow selected a little bit or somehow manipulated it.
No, one of our values would select how many towers with certain heights. So we, as an input, we had like 4 towers for each level. So we have like the maximum number of towers for the maximum height is 4, and so on.
Yeah.
So yeah, we know that the best solution is having all the towers with 25 meters.
Exactly.
Yeah,
so
but yeah, we selected to have maximum of 4 towers, yeah, with that height.
As an optimization problem, it's a little bit ill-defined. You're not really like, you don't have enough constraints to actually come to a conclusion. And that's what I'm saying. If you added some, especially some that actually matter, it would really help you. And the last comments, like I think that's like similar to what Arthur was saying. So you have like these minimal surface. Minimal surfaces were used from like, I don't know, Fry Auto for membranes, right? But you're using wood as well, right?
Wood?
It's wooden structures, or is it not wooden structures?
Yeah. Basically, we tested with wood, and we had a lot of tension. That's why it wasn't working well. So
Okay.
yeah, we're trying to use steel members, and I think regarding your question, if we took a step back to do a lot of other things, I think it's a matter of construction process, because it's not meant to be concrete at the end, but we were offered also to use wood as you said, like all of these elements, wooden elements. So yeah, basically we would take a step back and think more about the construction process. Yeah.
I think that when you have like, let's say a certain like I don't know, kit of parts, or like certain like, you know, materials, or certain like construction processes that you have to follow, you can inform your computational like let's say, or morphological like kind of like computational methodology as well. So you don't select, let's say, an algorithm, like for example minimal surfaces, like a geometric algorithm, completely independently of what your structure will be in the end. It's good to be more kind of like true to your intentions in terms of construction. So like use the right algorithm or the right geometric representation of the material or the construction process you will use. But overall, I have to say your presentation was really great, and I really loved the sections and the animations in the end. It was really very informative and to the point. Thank you for that. So great amount of work from all of you, by the way. You have very little amount of time, and you're like all working from home. Most of you are professional, like, you know, you also have like a real job to do. Not that this is not real, but yeah, you get the point. So last group 3, I think that you've done an incredible amount of work. I like the branding. It's not that important, but yeah, the work was really great. Unfortunately, Carlos took my best comment here. There was a tree that you positioned like underneath the shade, which is like very, very weird, if I say so. I think you just plotted some trees in the end because you wanted to add some vegetation, but vegetation is design. It's not like something that you just can plot in the end in some places. Maybe we're both wrong and the renders were not helping, but it looked like some trees were like positioned under the shade, which doesn't make sense because the trees are the shade. I think I will say it again please answer if you want.
Yeah, no, I'm saying like both of you were right. We're not gonna reject that. Like, you know, we call them Lumion trees these days. You know, it's the one that you're trying to put at the end. But definitely something that one of the major criticisms with yourself is like there are many layers that weren't treated as part of the design at the beginning. Like the vegetation is not on a makeup. It's a design layer.
Yeah,
that should be actually put it at the beginning. And also, like we struggle a lot with the bridge in terms of as a typology, and we learn a lot. But we wish as a team like we would be able to then integrate much better and much earlier sustainability and structural principles that help us to inform, like also, or like also Arthur said, control the curvature better, that help us later on the structural and the optimization and so on.
Nevertheless, you have a really sound methodology. Yeah.
May I add my 5 cents about the trees? You know, the bridge is primarily an engineering and not an architectural thing, and the trees are heavy. So it just happened that the only place where we can locate the trees is where we have the leg, and that's also where we have the program. So yes, your comment is fully accepted. It did create some mess in the end, but the only thing I can say to justify ourselves is that our bridge is oriented mostly north-south. So the shade that we have created blocks only part of the sun, and the trees do play their part in the overall shading in other hours.
So one thing that I could say, like as an additional comment to that, it's, you know, you say you're adding a tree to the bridge, and it's like it has to be right in the middle, because otherwise there's kind of structural issues with that. And then you have all these kind of like membranes, or like, you know, shading that you're using membranes to kind of like achieve. What about like using vegetation, and also seasonal vegetation, which perhaps could help you, like, you know, I'm not sure that would work in Cape Town, but yeah, you know, what about like adding vegetation in the design? I think this is a general, like, if you had it in the beginning, you would probably have a different approach. And one last comment, if I may. I think, still, I've said this before, and the structural engineers in the room should like correct me, but I think there's too much wood. You could have a little bit less wood. That's my take. Yeah.
Yeah, we did think about the vegetation on the sides as the screen shade, but frankly, we just didn't develop this idea.
Yeah, I think it's a time constraint, but definitely, like
Yeah.
you said, we'd definitely like it to be able to introduce that at the beginning, because I mean, how we can block the sun in summer, and then when it loses the leaves in winter, is perfect. So, and also, I mean, the structural optimization, and Andre can say that was a challenge, because then we needed to add in more wood to make it more sustainable, but also more structurally reliable. But then also it's such amount of wood that also at which point it became sustainable, when you have such a mass. So that's also an analysis that we would like to do one day, like to be able to really address how sustainable it will be and through which limits, and also if the wood is local or not, and so on. Yeah, thank you.
Anyway, congratulations to all of you. Yeah.
Yeah, Herman, I was gonna say on that, that's a really good point. Like, when does wood does not become sustainable anymore? Like, and that I guess relates to our studio, but I think that's where something like a life cycle analysis could be helpful. Like, how much volume of wood are you using versus which wood? Where does it come from? You know, this would be helpful for all your projects, to be honest. There's a few plugins that do life cycle analysis. I think Tortuga and Bowerbird, or you can look into it for. Yeah, but it's a great question.
Yeah, also it's otherwise, you know, we keep repeating wood, and then we create this kind of wave of like, we just need to use wood, but wood is not always great for certain scenarios. So definitely, we would love to be able to get to that analysis, but also it's quite an intense one as well. And unfortunately, have time, but it's really interesting to look for.
Well, our problem is probably that we have attempted to design something too big for the studio that long. But yeah, it was fun. And actually, we had a question in the end that we have placed the disassemblyability of the bridge is one of our objectives. But actually, it is so big that that's something you don't want to take apart after you have built it, even in 50 years. Even after the railways are gone, this is a structure that would rather stay and become something else than a crossing. But that can be that can't happen with wood, which is affected with ultraviolet and so on.
Great, thank you everyone, and thanks for the jury. I think it's great for all of your projects to have feedback from experts who are actually working with this in real life projects and real life construction projects. Rodrigo, I think Rodrigo is also with us.
Yep.
Right.
Hi guys, I've been in background for a while, just listening in. Well, I've seen the presentations, and I'm very happy to see the results of everybody. And I'm not gonna obviously stay here much longer because I don't want to delay the presentations. But I agree with everything that has been said today. I think there's a lot of advancements and in terms of design and the integration of the different aspects of how a project becomes architecture, and clearly in this case materiality was a big topic that needs to be solved. But obviously with the given time we cannot expect that these are all fully resolved issues. But I'm glad that the jury took a stand on this, because it really help a lot on the way that the projects can be projected in the end, you know. So I hope that all the comments were taking it well, because all the projects here they have a lot of potential. But yeah, I don't want to really go into much more. Thank you very much, everybody, for the presentations. I even see like more you advanced much more as well in terms of the development. So I was very happy to see the from renders to some ways that you decided to represent your geometry. So thank you very much, guys.
Great, thank you, Rodrigo. So we are now preparing group 6, group 8, and group 1. Group 6, you can take it away.
Do you see my screen?
Yes, Paulina, give it a minute, it's still loading. Yeah. We can now see it.
Okay. Okay, well, let's start then. Hello, everybody. We are group 6. It's Amau and myself, Paulina. So we have several aspects in this presentation. First, we'll look at the site, because I think it's very definitive of our project. Then we'll go through our manifesto, because it really triggered a lot of the research that we did. And then we'll go to the actual project, the design process, and the optimization and the drawings. Our project is located in Melbourne, Australia, in a residential area called Mordialloc. It's very close to the ocean and also to a beautiful natural reserve and a river that is joining the ocean. So in regards to our site, you can see it here highlighted. It is in an area that is just adjacent to the park, but a lot of the area hasn't been developed yet. The biggest development that is on our left is a college that has been there since the 19th century, and it has been expanding. So it's very likely that on the left, the college will expand towards our side. And the other two lots will be most likely taken by residential housing. We did quite a lot of research on the site. Actually went on site, took a lot of photos. It's a very communicative place, and it is actually a little bit hidden, but there is a lot of traffic, like pedestrian traffic, because next to the river there is a bike track and there are a lot of schools in the area, and there are kids basically that go most of the day through here. So we were looking at the residential area as such, but also thought what it could be the business opportunity there. And the closest cafe is 15 minutes away, and definitely the park and the schools and the residential area with the cafe works quite well. So we thought we might mix our program a little bit with and make it mixed use development. In regards to the building footprint, we had to take a lot of assumptions because we don't have real neighbors, but then we had to kind of imagine what will be happening. And since the college is most likely going to expand, they're probably going to follow the same street elevation that they have been following so far. So they're oriented towards north when they're interfacing with the park, and they're following the straight line. On the other hand, the residential housing, we don't really know what's going to happen there. But if these two lots get developed, our building is actually going to be quite hidden from the main streets. And our main elevation remains the park, which is quite important because a lot of people pass through there, and also from the other side of the river there are a lot of developments that could see our building, and there is a train line as well. For this reason, we think that we need to stick with the college arrangement, basically. In regards to program, we mixed, as I said, the development residential apartments for active people, because it's a very sporty area. A lot of people do paddleboard, biking, skating, whatever sport you can think of. It's just 5 to 10 minutes away from there. And then about the cafe, we thought we could make something more interesting, like automated cafe that could be fully roboticized. And for this reason, we have allowed for a significant service area. And we thought it would be good to engage also with the river and have, let's say, some boats part of the cafe and drones flying in and out. When it comes to our site analysis environmental climate, we are in a typical Victorian mid-temperature, fully humid and dry climate. And it is very different from Europe, like, let's say, the winter and the summer. There is not such a big amplitude. And we did a lot of simulations to understand the climate, actually what we could tackle as optimization. And I think our biggest take from all those exercises was that there are a lot more days in which we'll need heating compared to the cooling. So this led us to the idea that we might use some sort of a design a process or like design optimization so that we can reduce the cooling in the hottest period, which is usually December to February from 11 to 3 p.m. And that's why this is basically the core of our optimization. In regards to our manifesto, we were inspired by Bauhaus, and we did some sort of a modern read of their manifesto and tried to define some of the core principles that are applied also today. Bauhaus were looking quite extensively at prefab from the very beginning, but probably not the thing that they're most famous with. The thing we wanted to explore with prefab in more particular is create with regular shapes or like repetitive shapes, different spaces, because I think that's the biggest challenge when you do prefab. How do we create spaces that also don't get repetitive? That's one of our design objectives, to achieve some sort of a fluidity with prefab. We also wanted to see what could non-centralized circulation in a building look like. As I mentioned, we wanted to do some optimizations in regards to the solar gains and also structurally for the modules. So this is one of, I think, the defining concepts of our project is that we don't have a central core. We have small cores like vertical transition modules that go around the whole building, which creates some sort of a landscape, and the floor plan on every story is different, and logically also the spaces are different. And we decided to start simple in regards to main modules definition. We defined two modules. One is a rectangle, the other one is an L-shaped module. We wanted those modules to be able to work both horizontally and vertically. And that was the thing we were actually exploring mostly with our structural analysis. So we are using COT as a building material. And you can see here an example of the transitions in the building. We did quite a lot of kit of parts like analysis. Basically, a lot of parts that we went through, but yeah, at the end we finally find something that we were happy with. And now Aman will continue with the design process. Hello, Aman? I don't hear it.
Hello, everyone. Yeah. So basically, we started with defining our design workflow. So we started with our site parameters, and then we started from the computational process till the end result. I'm not able to scroll the slides. Yeah, so basically we started with the our buildable area. We looked at our adjacent land uses. We have the school and we have the residential areas. So we can define our orientation of the building. We also looked at the buildable area that we are eligible to build, which is 40% of the land. And basically our views is the river, and we looked at our access network. Then we defined our height limit based on the adjacent building average, which is 15 meters high. After that, we started with voxelizing our building by populating voxel center points to populate our main volume. So this is the first point that we started from. Then we started setting our linear attractors. After that, we created our voxels, which are 3 by 6 and height 3 meters. Then we started creating our first iteration. We noticed that we have a direct sunlight, no self-shading. Then we decided to rotate the middle plane, basically rotating the linear attractors toward north to minimize the sunlight and for the best views. So we got to iteration 2, which has less direct sunlight and more self-shading. Then we looked at our access points to the site to define our circulation, and that also defined our inner circulation. So basically, we wanted to uplift the ground floor for cross ventilation and wind flow. Then after that, that also defined our interior circulation, and we wanted to create a vertical atrium for vertical ventilation, and this is the optimized volume. Then we took it from there. We started allocating our program. We have the residential area towards the views, and we have the services area at the back, and we have the commercial area. So after that, from the voxels to the zones, and from the zones to the frames, we wanted to have a design strategy for our facade. So basically, we have the frame, which are negative, and we have the solid wall, which are positive. We started tracing the facade pattern based on the frames that we created from our zones, and we started creating frame tiles, basically, frame tiles, which are the negative, and the solid walls, which are the positive. And we started creating the rules. So basically, between two negatives, which are the frames, we have one solid, which is positive. So basically, the negative can go in XY axis, and positive can go X and Z axis. We wanted to create a frame strategy. Basically, our frame consists of beams and different beams. These beams split in different places based on force flow. Although they are split, but they maintain a closed loop that can be doubled to maximize the rigidity and strength, and can be maximized only on corners if needed. So basically, this is the sum of all the systems that we have: the frame system and the solid walls, and then we have the hybridized system. So we started with the beam, then we created our frame. Then we have our spaces, our modules. We started looking at different typologies of these modules. We have terraces, can be like communal spaces, can be commercial spaces. And we started looking also at the material, if they are like wood, made of wood and timber. For the structure analysis, we test our building in 3 different aspects: as a cluster, and as a frame, and as a beam. So basically, from structure utilization, the frames performs well by itself, and the force flows between these splitted frames. For the cluster analysis, we wanted to test the frames as shell analysis. So the frames were analyzed as a cluster to test the performance of the depth of the frame that have maximized the rigidity of our building. And we also created a mesh line analysis to analyze the bending and the compression that happens on these frames.
So we did a lot of iterations of aggregation with environmental criteria. So we had 2 criteria. We had a defined volume, and we were aggregating in it, looking for the maximum area, but also minimum heat solar gains in the cooling period between 11 and 3 p.m. I guess we didn't really stick to the final result, like the best ranked solution, because our optimization needs a lot more information in regards to the facade, where we haven't managed to get to yet. But on the other hand, this data has been very useful because we can see the range of iterations, and let's say one option that we like, we saw that where we are standing in terms of the other options. So this is a typical floor plans that are generated by the aggregation and the elevations. Here is a section, and basically this is we still need to add the facade and do a little bit more work, but yeah, that's it. Thank you.
Thank you, Pauline and Amal. And Abdulaziz, can you share your screen and prepare your presentation?
Hi everyone, do you see my screen now? Do you see my screen?
Yes, we can see your screen.
Yes. Yeah, okay. First of all, I would like to say something before I start. This work would not have been possible without faculty and colleagues' support. That's I'm really appreciate and thankful for them. Okay, let's start. My project is it's trying to solving something is a problem or social problem with the students housing program in Saudi Arabia. Um, this the top view of Riyadh, and we have different zones in Riyadh, which contemporary and skyscrapers zones, and in the another hand we have the traditional and old cultural souk. But in between of them, the students, one of the most students' problems here in Riyadh is about housing costs. So many students go to work to cover the expenses with the traditional or traditional souks or in the cultural or old zones, but it's the far away from the contemporary or the new urban planning in the city. So my project is to become between housing and market or bazaars or public area and environmental as well. Okay, my context, it's become in the north side of Riyadh city. It's become nearby university campus, and between the university campus and our site, it's become crossed by metro station under construction. Our site is already used by students. It's empty area used by students for every Friday. They selling the product, and for example, if you see the bottom picture, food trucks and some handicrafts to increase their incomes. So we see here our temperature hourly per the year. It's become the hottest period. It's become from January to September, and the critical hours. It's become here. You cannot go outside because the temperature is more than 46. So also we have the wind rose per the months. So we have also case studies we following or see the Canadian Muslim Sabadi architect at the aggregation units, and also Japanese architect Kurokawa or Remkolas between the aggregation and reduction of units. So our objective of work, it's become affordable housing for students and climate comfort and socio-urban. What that means between social and urban. It's become one terminology, and ventilated as well. Our workflow become with a different criteria, using different tools. For example, for generic optimization, we use the Galapagos, and for structural analysis, I used Caramba for wind and environment, wind for AD3D to generate and engine the wind. For environment, I used Ladybug tool to find or finalize my design. Assembly of my project. It's become following a modular grid. It's become 3x5 for all my my area. After that, I just reduce it between from my neighbors. This become about it's more than it's about regulation. Then I just increase my building with the same unit of capsules. then I reduce or reduct the capsules. This become for public area and bazaars, which will operated by or will use for or by students. Now I determine the vertical circulation, and also I use that one to simulate for structural. But however, I saw it's not enough. So what I did, I add an external or escaping staircase to reduce the mass load of building and to help the vertical cores in load the slabs of building. This is our vertical cores. This is our escaping staircases. Okay, now I saw the from the north side become high pressure of wind facing our building. So I generate to reduce by generating attractive paths to subtract capsules from my building. Okay, then after that I again simulated or generate the same simulation to see the differential between the previous and the new one, between the wind pressure when the facing of my building. Now the third one, it's about choosing my vegetation. My vegetation, I saw by the sun bath, it's the highest hourly or sun rays facing my building. It's become to the rooftop. But rooftop, in my opinion, it's useless if I just put a vegetation or just put grasses there, because nobody will be there, and as well it will be water consumption. So what I did, I choose the lower degree of facing of the rooftop, to make 50% of sun rays, which raising the facing of our capsule, to choose the places of vegetation. Now I see it's become again about the structural. I saw the cantilever above the shading area of bazaar and public area. It's become a little bit displacement. So the highest, it's 3.6 centimeter. Then I added a bracing steels around the faces. But I choose the highest utilization to add the bracings there. So when I added to the highest utilization faces, then it's become 2.5. It's different displacement between before and after adding the bracing steels. Enveloping of or skin of my buildings, it's become depending on the activity inside my building. That's mean I come back again to my plans to show what activity there. For example, what kind of capsules I have, how many, and what kind or types of capsules I have. For example, or also if I have LC rooms, for example, study rooms, coffee shops, etc. of activity there. So it depending on that, I changed the pattern of openings. Then I just open it for all of them the same offset of openings. After that, I saw the sun rays or radiation of sunlight become on my buildings. After that, I will decide the openings, and I generate which the sun facing directly on the facade or on the capsule faces. it will be decreasing the openings. On another hand, especially on the north side, it will be which not become facing or the sun. It will not facing or touch the faces. It will be big openings. Now I just calculated how many precast fabrication we need, and we can calculate it how many we have. On another hand, we can just take the standardized from the factories or from precast concrete from the market. My program here, the ground floor, it will be for information desk, coffee shop. The first floor, it will be stationery, laundry, study rooms, coffee shop, either. From the third up to the eighth floor, which is the highest floor, it will be for housing. Now, what I did here again, I start from one capsule, which is 3 by 5. Then I'm trying to iterate or make it a double. And what I can to find this 6 by 5 type A, this 6 by 5 type B. It's same dimension but different content. And 10 by 10. It's the same modular what we can get. 6 by 10 L shape. The same different content, and now here we just get the ground the plans. We can to see it after we decide the iteration or different double or variation of capsules. This is our first story. This the second one, third one, fourth, fifth, sixth, seventh, and eighth as well. And this is our section. Now this is our visualization exterior render. This is our escaping staircases. This become under the public area. And here the traces between the different levels. And here, if you notice that in the right side, if you see when the neighbors or the context of buildings from the south side, it's casting shadow on my building. That's because showing giving a biggest or bigger than the highest floors about openings. That's it.
Thank you, Abdulaziz. So group 1.
Yep.
And let's try to stick to
Can you see the
given time.
Hello.
Yes,
Hello?
we can see the screen now.
Cool. Yeah. So good evening, everyone. This is group 1 with Alex, Krishna, and myself, Keshav, and our project is titled The Modular Edifice. So why modular is because modular objects have entities which repeat in each other, for example, like cells. Modular thinking can also be linked to sustainability, as a framework used to build one module can be repeated to other modules, hence saving material, money, as well as time. Modular also allows for phase-wise construction, which can also be attributed to sustainability. So our project is divided into 8 parts. So the first part is site analysis. The site is located in Mumbai, India. It is located on the eastern coast of Mumbai in between 2 main roads and a rail track. The site is very accessible by road and rail, and the nearest railway station is about 5 minutes walk from the site. The site lies in between the commercial and the industrial parts of the city. It's a green land lying largely barren because of the construction activity and the shipbreaking yard nearby, even though there's a lot of greenery in the site. So then we map the noise levels in the city, and in the site, the the noise levels are more than the safe limit throughout the day, as we can see in a research paper here. Hence, the building should be placed in such a way that the harmful sound does not penetrate the site. Then we went on to understand the environmental aspects of a site. Most of the radiation on a site is incident from the south, and the most predominant wind source is from the west. Wind is very critical to a site, as the site is very humid and cross ventilation is absolutely necessary. So with these factors in mind, we formulated our design strategies. So the first objective is to use modular thinking as a way of sustainable building almost entirely in timber and using upcycling as a carbon reducing sustainable approach. To look into how non-visual aspects like radiation or sound shape the design, to integrate active environmental systems that optimize the environmental aspects, to address the lack of public space in Mumbai due to high density, and to increase the quality of public and social life. Then we went to adopt some design strategies to fulfill these objectives that we set for ourselves. So the first objective is to shield the site from noise by building along the boundary of the site and leave the rest of the site open for public. To shield the building from strong light from the south and the west by placing a second skin. To promote views on the sea on the east by increasing the building height. To break down the building to allow for cross ventilation throughout a building and also for public access. Then we went on to understand the programmatic potential of a site. The proposed programs are co-working space so that the commercial and industrial potential of a site is harnessed, and to provide connecting pedestrian paths through the site for interaction, which is ideal for retail activity on the ground floor. Then we went on to formulate the different programmatic requirements of a co-working space, which are open desk, shared spots, private meeting rooms, conference rooms, library with other public facilities. We divided the modules into 3 different types, small, medium, and large, depending on the sizes required for each function. Then Krishna can take over.
Yes, so from these defined functional units, we develop geometries made up of same numbers that can be repeated and aggregated to function together as a building. So we looked at this regular tetrahedron as the initial grid for stability and repetition of the same members, and then developed various forms out of it, and finally arrived at this truncated tetrahedron form, which allows for maximum interlocking and leaving no space behind, and also creates a very rigid structure. So the final modules are of 3 types. Type 1 is a small module for retail and private offices. Type 2 is a medium-sized module for larger retail, showroom, restaurant, etc. And type 3 is the large modules for the office blocks. So then we analyze this units further by integrating various functions into it, and saw how a single module can perform in terms of different functions. And also we analyzed how different types of modules can perform together in supporting one single function, as in how these 3 modules come together in supporting one function. And after defining the local geometry of the parts, we then looked at how we can define the overall form of the whole, to which the modules are aggregated by using evolutionary solvers to create a sensible design with respect to our manifesto. So this started at the site level, and the first step was to integrate the public paths and the retail spaces that supports it into the site as a measure to addressing the lack of public space, as we discussed before. For this, we analyzed the site in terms of thermal comfort, and we observed that due to the large scale of the plot and the absence of significantly shading context buildings, the thermal comfort level is relatively uniform throughout the site, except for the regions with denser vegetation, which shows relatively higher thermal comfort percentage throughout the year. So we decided to retain these and develop these regions into landscape green zones to which the pedestrians are attracted into. Then we looked at the roads that form the site on all sides, and each of these roads have their own distinct character. So the one in the red that you see is a street with a high pedestrian activity, and then we have the one on the right which is a expressway and really has relatively low pedestrian activity, but has the connection to the railway station, and is a potential for bringing in higher pedestrian activity. And then we have the third road, which is connecting these 2 roads, which is ideal, which has a very low to nil pedestrian activity and vehicular movement, which makes it ideal for the vehicular access into the office building. So then we define these access points into the site, and the priorities of these access point is based on the existing and potential pedestrian activity as discussed before. And these access points then converge into these green zones, forming a network of paths, and these paths are then further developed based on their priority, form smoother pedestrian walkways. So from these parts, we combine the larger areas that are left behind, and this forms the initial building footprint, which is then further optimized. So Alex can take over from here.
Yeah. Yeah, of course. We got a little bit messed up in the slides, so can we get to the first one, please?
Yeah.
Yeah, so then we went on and took all the inferences from the earlier analysis to prepare the Wallace simulation algorithm that helped us to achieve the initial form of the building. We took 5 main objectives, which is the minimum west exposure, maximum east and south exposure to promote views to the ocean and to increase the shading of the plot. And then we constrained the volume, and also the main aspect was to reduce the overall radiation by self-shading of the building. There is some connection issues. Then we took the inferences from the simulations and we compared the volume, the radiation, and then we arrived to the final form that fits all the criteria and also that we liked in terms of the design qualities. Then we went on and tried to integrate the form with the modular part of it. So we have our truncated octahedron. We used to aggregate it to create the initial cluster, which was the first step in creating the final shape of the building. This is a quick animation showing the random aggregation. Then what we did, we took the initial aggregation, analyzed it with Caramba. There is some issues with the connection. I'm so sorry about this. And then we specified the grid direction on the site. Then we arrived with the final aggregation and the site plan. And then we went on and continued to prepare the Caramba analysis. Here is all the parts of the Caramba model for the structural analysis that we prepared. We specified 3 main result cases, which is wind load from the predominant directions, which is west and north, and also for the floor load and gravity. Then we analyzed the model in different ways. The first one was the shell model. The second one was the beam model. We analyzed the flow lines, the force flow lines. Then we analyzed the beam model. And what we took from those structural analysis is we analyzed how can we reduce the overall mass of the building, how can we achieve the better stability and less carbon footprint on used materials. We aim for using the timber, rectangular timber sections and timber floors. The inferences that we got from the Caramba analysis were that by introducing the steel core in the middle, which will be very light, we can reduce the overall mass of the building and decrease the overall beam sections. We also, sorry for the connection, there are some connection issues in here. I cannot, probably the India to Europe connection travel, because I would like to go back to the slide where we show all this. Yeah, and we also found the parts of the building that needs to be reinforced. Yeah, but I'm extremely sorry for the mess with here because I just cannot go smoothly. Okay, yeah, those are the parts that are working too hard and needs to be extra reinforced. Yeah, let's go next.
Cool. And so then after the structure inferences from the structural analysis, we went on to conjoin some modules to form larger clusters with larger open floor plans required to form the different functions for the build form. So the next few slides will show the individual function position and the configurations of the clusters. So yeah. So here you can see how the meeting rooms and the large office clusters have free open spaces in between. So yeah, so this is how the clusters work, and then Krishna can take over from here.
Yeah, after the clustering of the modules, the next step for us was to provide circulation connecting to the different clusters. So we followed a similar language, and where we developed the vertical circulation modules, and those connect the clusters at various levels, as you see here. Then we look at how the paths function as a whole, and as you can see in the plan, the different clusters connect together horizontally as well, and most of these connections are through these circulation modules. And here we have a section through the same where you can see the circulation modules connecting different levels, and the voids from it form an atrium that is not purely vertical but is more dynamic depending upon the circulation path that you take and the level that you're in. So taking a closer look, we can see how the horizontal and vertical circulation within each cluster take place, with the function flowing from one module to the other. And here also we see the initial geometry or the initial internal geometry obtained by clustering can provide flexible solutions that adapt to the programmatic requirements. So, and then yeah.
So the last part of the problem was to how do we integrate the envelope with the rest with the rest of the project, because we had to protect our building from the strong radiation from the site. So basically, so as per the environmental requirements, a facade had to be designed to block radiation from the south and also wind flow from the west. For this, we decided to upcycle existing unused fishing boats to generate a module. As you can see here, the active shading module is designed to block most of the radiation from the south and still have the west part open to allow for natural cross ventilation. Then Alex can explain.
Yep. So then we analyzed the facade based on the radiation intake to specify the areas that we use for the platform for our envelope. This is the most. We analyzed the range of the radiation, and we picked around 60% of the most highly radiated parts of the facade and used them to plant our modular facade on top of it. Then we developed the active system that reacts to the sun position based on the sensors and the pre-programmed day function. So here's the animation where you can see how the facade opens and closes based on the time of the day. And then we analyzed using Ladybug how actually by opening and closing the panels, how the radiation intake of the building changes from fully opened to fully closed in the biggest radiation period, which is winter for Mumbai. Yeah, and then we prepared some visualizations to show our project a little better. So Keshava can go on from here. There are some really nice interior pictures.
Yeah. So I mean, so yeah, that's it. So here you can see how the building is integrated with the context, and yeah, so that's it.
Thank you, Keshava. Thank you, everyone. So I think we can go through a very quick round of feedback as well.
I'll let someone else start, so then we shuffle the order.
Carlos?
Angelos, you go.
No, it's okay. You go first.
Carlos,
Okay.
he seems ready.
Taking notes here like crazy. Well, look, guys, wow, impressive. I like this kind of grouping of projects, the way that you have classified the projects, and I like the fact that you guys are doing this modular thinking and developing like concepts around it. Because I think like modular, obviously, as you said, guys, it's like it's a tricky business. You know, we have to do modular stuff, and just for one side, you want to please your client and say, no, everything's going to look different, but it's going to be modular because it's going to be sustainable. So I feel like it's quite a challenge to design sustainable architecture that meets all the requirements of aesthetics and climate demands. But I think it's nowadays kind of very important that as people are looking at that thing, and students are especially studying how a modular building can be more sustainable and why. You know, the reasons behind is what I really like. So I think I'm going to start like quickly with the first theme with this about house modular thinking. I think it's quite interesting the way that you guys are optimizing the box cells. And I think it's like something very important to look at when you're developing something like that is like to put together also information about what we said at the beginning, all the materials and all the structure and all the energy, especially you guys that you're doing like modular stuff. Energy is like, again, one of the main things that you need to look at, because depending on the size of your model, the configuration of the facade, the element that you're going to have, the materials itself, the energy consumption is very way different. So I really miss a little bit of information about it, and I feel like for the future it would be good that you kind of work on that thing. But I like the fact that you also put together the idea of reducing energy exposure or like solar exposure. I think it's kind of like a really good index of that in the future we have a massive impact on the consumption of the building. So the fact that you started with that thing is also like a good point when the engineers take over. Last time that I hear also in the office, we just talk about it like let's look first at the basics of solar exposure, and then engineers that are doing all the energy modeling will be able to ensure like good results. Because if you send to an engineer something that is not working from the beginning because you didn't look at the solar, then it's a really complicated matter to solve with like solutions. But I think overall it's kind of like quite interesting the way that you propose it, and the fact that you're working on the other side of the globe is also tricky because people from northern European thinking is always like you have like hot summers, cold winters. When you go to the other side, it's totally the opposite. So it's a great plus that you took into account the climate studies and everything. So I feel like it's quite good. I'm really happy to see people working on that direction. So for you guys, Abdullah, and your student accommodation.
Abdulaziz,
sorry, man. I apologize for that. Abdulaziz is quite interesting proposal. I think it's like very good that you also did optimization, looking at all these parameters of how the facades need to behave differently depending on the orientation. So that's something that is really impressive that you put together all this. I'm just only curious about something. Do you know that in Riyadh, in Saudi Arabia, there's something called Mostadam? Do you work with that thing or you hear about it?
Yeah. Do you mean Mohsen?
Mostadam is like a certificate, like similar to LEED. And it has quite interesting points that can help you to drive your research. Because the way it's structured, it gives you even the results on the things that you need to look at, like LEED would do the same way. But specifically, this one is suited for this extreme climate in the desert. So I know it will because it's something that we have been using a lot in the office. But I would recommend you.
Could you give me his name again?
I will text it later, so I will send you a quick link to it, so you can have a look at the thing.
I will.
But definitely keep in your head that there is a specific standard for your country, or at least for you. I don't know if you're from there exactly, but it's quite well suited for the extreme weather, because when you're talking about this super hard kind of difference of temperatures in between the morning and the day, don't think only on a building in the desert as something that you need to protect from the sun, because at nighttime you have to protect it from really low temperatures. So all the climate in this country is quite extreme. So think about it from both sides. And also, I recommend you to look at passive strategies. I think nobody has been talking about passive strategies for cooling and for protecting buildings. So I feel that's something that you guys could research on, because your buildings can change a lot if you're trying to integrate like passive strategies for conditioning the interiors and also for protecting the people in the exteriors and comfort as well. it's something I miss a little bit of information about how would you deal with the comfort levels of your building. But I think it's quite interesting. And yes, I mean, just we'll send you this information later so you can have it, so I don't take too much time here. And now for the Mumbai team, well, look, guys, quite impressive research and quite impressive results at the end. I really like the way that you put together all this modular thinking with the octagon, because it's kind of like a very challenging shape to really deal with in architectural terms. But I think it's quite interesting the fact that you study the way to aggregate those elements and your optimization to really at the end up in that shape or in this kind of aggregations there. I really enjoy the way that you were talking about also thermal comfort. That's something not many people take into account, all these thermal comfort concepts. So it's quite interesting you did it, but again, not many information about embodied carbon in any of the three projects. And I feel it's a really key thing when you're talking about modular architecture. But look at why the materials are important. Talk to manufacturers, do some research online, because embodied carbon really need the manufacturing information. It's not that you do it on your own with an analysis tool, because as Arthur and Hans were saying, like transportation costs are like really important. I've seen projects made out of timber in Mumbai. Actually, we have one in the office, but everything came from Germany, so no, from France. So the manufacturing facility was in France. Transportation costs were like insane. So the whole thinking of let's make something out of wood. But wait a second, where's the technology to develop this beautiful modular architecture, perfectly developed and polished for it? Yeah, no, it's in France. It's like, okay, so all this thinking.
I just have a question. So why was it taken from France? Like, was it because of technological reasons or?
No, the material came from somewhere else. So it's not even in France that the wood was there.
Okay.
But the facility for manufacturing the elements were there.
Okay, manufacturing. Yeah. Okay. I mean, that can be a problem, but because wood is, yeah, it's because wood is abundant. But yeah, I mean, manufacturing can be an issue.
Yeah, but we use the same amount of the same length for all the beams that we use.
Yeah.
So
that's a good point.
it's a very how to say there are only two lengths for the beams, and the shape of them is it's not unique shape for each beam. It's almost the same shape for each beam that we have, except like for the bigger modules, and there's like a smaller beam for the smaller modules for the envelope. So it's very easily fabricatable, and it can be done on place, and we can focus on using the material that's already in India. Like we analyzed what's the most used timber material in India. It's actually the pine. Like one of the most used one is the pine wood, which we can achieve without transporting it from Europe or other countries.
I think that will be possible. The other thing is when you need to scale things up, you need to look at the industrialization process. Sometimes you get the materials in one location, but you don't have the technology to develop it as you are expecting. I've seen it happen, depending on where you find the compounds for doing the manufacturing, you will be able to supply the wood from the same location. But if for any reason your joint system is really complicated for a local craftsman to develop it, you will struggle to develop a building at such a scale. So that's another thing that maybe, I don't know if you research on which facilities are available, but that's something I think you guys can look at that thing. And also, if you're looking in India, just take into account Vastu. It's like a really interesting, it's like kind of the feng shui of architecture, but in India, I think you guys must be very familiar with that. But I've seen like projects being like put on hold because they are not meeting the requirements. And they basically have an impact on the sustainability as well. So the same way that Amsterdam looks at very much a lot of cultural things, it's kind of like sustainability standards that they talk about energy, but they also take a lot about cultural references and things like that to really pass planning applications. So it's kind of like a really tricky thing. So I would just maybe, I mean, that was my only suggestions, that maybe you look at these things, you will be able to polish the whole thing and develop a very nice final solution. But in general, it was impressive all the work you guys did. So I'm gonna stop here, guys. So let you talk.
Yeah, great. Yeah, maybe I go next. First of all, I think I'd like to say, and like, I mean, it's a little bit like weird to praise your own work, but like it's not really my own work. It's the work of Aris and Sara, that in all projects, like the first group and the second group, the level of environmental analysis is really great. And I mean, of course, there's many more things to look at. But if you think that you just started like 3 months ago, like, you know, it's just a semester essentially, and you've like already managed to kind of like fully analyze and explore, like, let's say, environmental simulations in quite complex projects, I think this is really an achievement. And yeah, I mean, maybe more specific comments. I'd say one thing that I'd like to say is like a lot of you have like this modular approach. So the first group and the last group of today's presentation, you have this like modules, right? And you kind of like combine them, and they're creating quite complex structures. But this complexity, the kind of like geometrical complexity that you add, it's a little bit like counter productive in terms of like, the environmental kind of like let's say approach, because first of all, you have a lot more material, a lot more like walls, a lot more like surfaces to deal with, a lot more like geometrical complexity essentially creates a lot more like let's say embodied energy. And also sometimes things that you might have like missed is like spatial let's say issues. Like, for example, the last group, you have this, like, it's a really beautiful structure, right, with the hexagonal kind of like modules, but you can clearly see in your section that that's not really working very well in the spatial configuration. And I was like, when I was looking at your presentations, both the first and the last one, like I always remember like a project I had at Foster's which was like essentially, in Cairo, Barva, we also published that project, which is like essentially exactly like, manipulating the balconies of a building to create like, self-shading or whatever. And it's always like, you end up with these kind of really weird configurations that don't really help that much. Let me fetch my more specific comments. So in the second group, you talked about vegetation, right? And you said that you looked at the solar radiation and you found the places where you got like most sunlight, if I get correctly.
Yeah.
But did you at all like consider like what kind of vegetation you're using, like how much water does it need, and like, do you really need more sun, or does it work with evaporative cooling at all, or like, because there's other issues in the vegetation that you could take into account rather than just saying, okay, this is where I get the most sun, let me put like trees or some kind of like did you elaborate on that?
Do you mean the kind of trees, or?
Yeah, the type of vegetation.
It's only, the vegetation phases. I didn't go too deep until to determine the kind of tree.
Yeah, I think similar to what Carlos was saying, perhaps like it's important to understand like the local kind of like local conditions and local restrictions on when you say, I'm gonna include vegetation in some places.
Yeah, what I'm looking for the hottest phases, it's just for shading more than, kind of.
It's okay. And one more question for the last group. These kind of like used or like kind of like abandoned ships, how did you, like, I didn't really understand how this comes into play.
We would like to introduce them as facade panels using the abundancy of the how to say it, the craftsmen that are in the area. There are also craftsmen, there are also people who can work on upcycling those boats into usable parts for our facade, and it will also create it will also differentiate the colors on the facade because of the different parts of the boats. Yeah, I think that's what we aimed for.
But I mean, like, there's a lot. It's not really resolved how this, becomes fabricated. Like, how it's like upcycled. Essentially, it's like it's more like a general concept, right? Like, 'cause it's a little bit like unclear on how that becomes a building component with all the regulations. So, like, are these like boats, I don't know, like plastic or like kind of like metal, or what kind of like material is it that you're using? And it's a little bit like vague. But yeah, I mean, I don't have any more kind of like more specific comments. I'd say I really like the environmental kind of like approach in all of your projects, and it's really well informed. Of course, I insist that these kind of like geometries that you use don't really help you that much in controlling, let's say, the conditions of the buildings. I don't know if Arthur has a different opinion. It's this kind of like discretization of the space. It's not always helpful. One thing, last thing, maybe perhaps in the environmental simulation methodology, you could take these modules and create, let's say, taxonomies of them, and then you don't really need to do like whole building analysis, but you just have a taxonomy of the module itself. You can say, you know, what if a module is like has one adjacent module or two adjacent modules or three or four, or like one on top or one below, and just by that, like, you know, by creating cases, you can like analyze, I don't know, like, you know, 12 different cases of those in a cube or something like that, and then essentially that gives you already the results for the whole building, and that allows you to do like way bigger solution search rather than like having to analyze the whole building. That's just the thought. Because for example, you could do like energy analysis on one module and then kind of like propagate that to the whole building, so to say. But still, there's some issues. There's some issues with the modular approach. Yes, that's my 2 pence.
Well, my turn then. I just to pick on Angelo's latest comment about having separate module and aggregation, because I think you guys are looking into that quite a bit. I think in a way, it's only helpful if it's part of the possibility of disassembly, you know? So it's assembly, disassembly. The metabolists did it quite a bit. You know, the famous one in Tokyo ended up never being disassembled. But there was an interesting idea behind the fact that buildings could not be permanent and not conceived as things that will always stay as such, and therefore have no waste whatsoever. And I think that's not a conscious thing that you guys have implemented in your modularization, because I can't see, for example, in the last group, how the two modules will attach. And the truth is, like, it's true that you know, the fact that they're this sort of truncated, I forgot the name of the module, but a truncated polyhedron.
Octahedron.
Octahedron, here you go. You know, a facade, like a building doesn't always need to be all that. Like maybe some bits need to be that. Some facades can be perfectly straight. And like we said for previous project, like the environmental design is like a sum of what's useful where and what's not useful in other places. I think generally, as all 3 projects, it's really missing questions of materiality and thickness. I think probably Amal and Paulina, the first project, was thinking of using off-the-shelf timber pieces that are then played with thickness given the forces. I thought that was really nice, but I wasn't so sure why the sliced angles, or because it's so much kind of easier to do straight. But I wonder what is ornamental, what is you know, how can I say, functional. It'd be nice to make it more clear. There's to come on individual feedback in groups. I thought the first group, you guys had a lot of bullet points at the beginning. It's much better to illustrate the function of the building through your render. Like one render with all the different activities will speak 1,000 times more than just a series of bullet points. I was also not so sure about the project was very rectangular in relation to a site that wasn't. I was curious to hear the relationship with the site, the landscape, because there's a lot you can do with landscaping and relationship between, and I think that's for everyone that we've seen so far. Like, you guys have modules put on the ground, but the ground itself doesn't seem to be affected by the modules. There's a lot you can do with the earth, with the ground, with the landscape, like thermal mass, and you know, you can also guide and you can also create a yin-yang relationship between your sort of aggregation and the way it impacts the earth. Then on Abdulaziz, I was quite impressed by the clarity of the whole thing. I was wondering the choice of subdivisions. Like, it seems like you have this cube on a rectangle. Sometimes it helps to have a relationship between the site itself and the modules or the aggregation modules that you're choosing. I just wondered if the cube was the right choice, if it shouldn't have been some kind of elongated module. The other thing you can do is choose this module in relation to off-the-shelf systems. You know, there is a very standard office dimension, I think 1.4 for like these systems that they sell for facades. Like sometimes it's better to inform a subdivision based on an off-the-shelf product, which is what Amal and Paulina has done, which I thought it was really nice. It's nice to combine parametric design with what you can find in the market, because then it's so efficient, right? Because you choose your material system and your products, and then you are able to inform a very complex technological way of subdividing the space based on something that's actually we know is proven and certified. I thought that was quite a bit of potential. I was not convinced by the window openings though, like these thin slats. I thought maybe it would be better to use the same subdivision you're using on the overall cubes to the small facade elements. Like there's always a nice fractal relationship you can find between the overall subdivision, the local subdivisions, and so on. And then Alex Keshava and Krishna Nuni, really nice. It's really nice. You know, I was talking about like telling your vision at the beginning. You guys put an amazing render at the very first slide. So you got all my attention. Like, I think it's so important that you start with what's strong. And I think everyone should sort of see that. And I love the rigor. I wonder how the modules are attached. I said it at the beginning, but it looks like they're kind of placed. And then the good thing about modular aggregation or this kind of design is that you can really detail one module, and then it's just a block, right? Or like a proxy, like you can so I wish it was more detailed, because I feel like you could have done this easily, you know, thicknesses and relationship between the windows and the timber, and how does that work, and which one needs to be an opaque surface, which one needs to be actual glass, and so on and so forth. Yeah, I mean, that's all I'd say.
I mean, in terms of the structural properties of our building, we didn't have much time to explain it in depth, but the overall usage of this truncated octahedron was to create a three-dimensional rigid grid that allows us to reduce the overall mass of the building thanks to the sole rigidity of the three-dimensional grid created by this aggregation. And so that's what I want to add, because it was not clearly stated, but like then we of course analyzed how this shape influences the sections and the overall mass of the building, which we also didn't have much time to explain for this.
It's interesting, Alexander, like the way your groups are, like the presentation that happened, the three of them, in a way, one cannot help thinking, like, what is the advantage of the truncated module versus just a cube, which was like, say, Abdulaziz's one, or it's kind of interesting to see like which one does what, because obviously the cube will have a much easier way to handle, like, I don't know, furnitures and stuff and so on, but it would be nice to know that difference.
Yeah, you can part it and separate easily, you know, with partitions, and you can double it easier than if it's another shape.
It's true, but there are also other advantages. I mean, obviously, it's also less a little bit more creative, and it creates an interesting facade that is a bit more 3D. So, and I think the 3Dness helps because it's more of a shell, so it helps with minimizing structures. It probably helps in sun self-shading. But I think it would have been interesting, Alex, to do a comparative analysis with something that is more basic, like the cubes.
Okay.
Great. Thank you, Carlos, Angelos, and Arthur. We also have David Leon, who is the master director, who joined us during your presentations. So, David, if you want to say hi.
Yeah, hi. I just want to jump in and say hi. I had step out of my paternity leave for a while and crash the party here in order to check out the projects that you've been making, and also thank Arthur, Angelos, and Carlos for joining the crits. I mean, there's not much I'd like to add after the comments that I've heard, but aside from the fact that I'm actually very pleased from what I've seen so far, and I want to congratulate Rodrigo and Oana also, and you guys for the projects. So hi, and I'll stick around for a while and see what I can see more.
Yeah, we're going for the third round now, and gonna hopefully finish up in a high tone.
Absolutely.
Great, Rodrigo. Do you want to add any feedback, or
Not
should we
really.
move
I
on
know
to
that
the
we're
next?
a bit behind time, so I don't want to hold the presentations because we have 3 more exciting groups to present. So let's go for that.
Great. So we have group 9, then group 4, then group 2 getting ready to present. And guys, please, yes.
I'm so sorry. That's when I need to go.
I know. Thank you
Cool.
for joining us for
Thank you so much, guys.
start.
Thank
So
you very much,
impressive.
Arthur, for everything.
I'm so impressed you guys did this in parallel to the other ones. Like, it's amazing, really. And you guys have like, I think the collection of all the work you've done is I'd imagine as an employer to receive that, I'd be like, you know, so impressed to know you've even done it from home, as in you can work from home and produce that.
Yeah,
I think it's really special. So congrats, everyone. Yeah.
Thank you.
Thank you.
Bye.
No, and thank you, Arthur, because you can really tell that how the other studios, the other seminars are coming together in this studio as well. So this would not been able to happen if it wasn't for you and Angelos and everybody else that is
It's a
involved.
pleasure. See you soon.
Yeah.
Ciao.
See
Bye.
you. Ciao.
Thank you, Arthur. So group 9, and let's please stick to the 10 minutes presentation. We are quite a lot over time now.
Yeah. All right. Just a second. Okay. So we are group 9. I am Navapan, and we have Beno and Jonathan right here with us. So today we will present about our project about the Bangkok residents. So we start with the site. We found the location in the central area of Bangkok, where is the plot which shows have the dimension of the 37 by 135. And where is the surrounding majorly are low-rise residential with one high-rise condominium on the south. So here is the image showing the site. As you can see, the plot has no shading, and most of our neighbors are low-rise residential, which will be considered in the climatic issue. And speaking about the climatic condition, we have observed and studied the people behavior related to the climatic data. Unlike Europe, Bangkok is the tropical country that people normally avoid facing directly to the sunlight, as it could easily burn your skin within an hour. So by living under the shading area, it would be a better solution. This issue will be taken in our consideration for further design principle. We also found that the Bangkok located above the equator, the solar radiation have some relation to the wind direction, which mostly directioning from the south side. And the overall temperature of Bangkok showing the hourly data of temperature within 1 year, with the average range from 30 to 36 degrees Celsius. So speaking in terms of energy for the building operation, we found that more than 30% of the housing energy consumption costs from the air condition operation. And therefore, we would like to propose our design strategy in order to help reduce the building temperature and also reduce the energy used for air conditioning. Meanwhile, also proposing a design based on passive cooling system with carbon neutral materials. In this project, Thai vernacular will be our model role as a principles for a passive design strategy. After we know the problem, the analysis will lead us to the opportunity to design the building elements, which we focus on how can we design the protective skin or the architectural elements to the decreasing of the temperature, that we expect the result of energy efficiency with the minimum radiation and maximum ventilation by passive cooling, and using carbon neutral for structural material and trying to use it as a major of the material inside the building. For a passive design strategy, I will give this topic to Jonathan to present.
So for us, it's really important to analyze first the Thai vernacular architecture, since these principles they were already working without air conditioning and so on. Our first approach was to extract these clue principles. So they are related, for example, to the bamboo for cladding, the timber structure, really important, the high slope roof for cross ventilation, the jetty roof, and an external shading, and also to lift the volume and to have an open ground floor to integrate this ventilation within the building. So we try to focus these strategies for our form optimization, and then we had the question like, how can we integrate these principles in order to have a residential volume that is taking into consideration this principle. In the following slides, we will see the process of how we managed to integrate them. The first one was in relation to the regulation from Bangkok. For us, was really important to play with the rules from the city. So the first thing we did was to set back this minimum 6 meters to reduce the volume and to be closer to the far indices from the place. We set a height limit of 24 meters. And we also created this concept that we call the box in box. And with this concept, what we want to achieve is to have a ventilation between an external skin and an interior volume. For this parameter, we set a domain for till 3 meters to set back. The next step we did was, and a really important relation to the radiation for the exterior skin, was to set back the ground floor facade. In this way, we could avoid the direct sun, and we could create a self-shading of the volume. Also, it would help us to reduce the interior temperature. For this one, we set it to 3 meters, the domain for the parameter. So as well as in the vernacular architecture, we opened the ground floor. So we uplift the building to capture as much ventilation from a pedestrian scale. But also we wanted to integrate this ventilation with a vertical element atriums in order to capture this ventilation and distribute it through the corridors and the common areas. But as well, really important, the slope roof from the vernacular architecture. So we created this slope roof in order to capture as much wind as we could. We set a domain for our parameters from 10% till 100%. And we also took into consideration the wind direction, which is coming from the south. So we oriented our roof in order to capture as much as we could for it. So the result is an integration of these ventilation strategies in order to have control of how it's the wind coming inside and the hot air it's going out. We run our optimization, and we got this final results. We can see it here in this table. We went with option 5. See, it is the lowest temperature. The inner temperature is the lowest one, and it is also in the roof we have the lowest radiation. Here is the final version, and the most important thing from this exercise is that the typical mean building surface in Bangkok, it's around 35.7 Celsius degrees. And with this exercise, with this optimization process, what the result that we achieved was to reduce it to obtain a volume with an average building temperature of 31.97 Celsius degrees. So we reduce more than 3 degrees the temperature of the building, and we also got the lowest roof solar radiation possible.
Yeah, now we come to the structure of the building. Here you see a diagram, which for the structure we propose a wooden building, except the core for fire prevention. The wood building, like this proposal, is for also for a carbon neutral building. As Jean was mentioned, we have the vertical ventilation. We use it for sure for the ventilation and also for the support for the building. We have no columns; it's a column-free building. This is also, let's say, sustainable for the long term of the building. On the next slide, we are playing around with Caramba, like in different elements, and here you see, yeah, we choose in the end the diagonal structure. Which takes quite good the forces. Is in a way of an abstraction of nature, which brings more connection points that the forces can flow, yeah, quite good with the wind loads and also gravity through the whole building. The forces will be divided on several diagonals. On the next slide, you also see we also took this pattern for different elements. Even we choose it for the roof or for the whole construction. We see it here, like what I was saying, like the displacement and everything. It's quite, yeah, let's say quite minimum. On the next slide, you see the facade. We also bring the inner facade to the outer view to also that it's visible. That we use this diagonal. Yeah, let's say structure for the whole building. This is what I was saying. Like it works on a lot of yeah elements, and we also yeah, on the next slide we also came to the facade concept. We choose to cool down the building, we need cross ventilation, and for this reason we choose the wind to play with the facade. On the next slide you see some on this slide you see like 8 direction of the wind that put pressure on our facade. We focus on the east and west facade. I mean, on the long side of the facade. These are the most important facade for the ventilation effect we need to cool the building down.
Yeah, so after we got mapping the 8 direction possibility of the wind, so we try to average the data and overlay with our structural facade. And after we implement the pattern of opening, like we use that according to the pressure value on the facade combining with the solar radiation, meaning like the facade that got the minimum pressure, it is more close, while it's like the facade that got the maximum pressure is more open. In this case, we can obtain more wind to access inside the building. So here is solar radiation will be our strategy to subdivide the diagrid in order to increase the self-shading ability to reduce the solar radiation. Meanwhile, the second is the opening area was defined by the wind pressure. And after that, we got the result of the combination between the opening and the subdivision of the framing. So we have the minimum opening for the facade panel with 40% in order to allow the daylight to access. And on the right side, the section show how the wind ventilate through the building from the southeast to the northwest. The roof is lifted up on the west side for better flow according to the wind direction. And also the building core will provide the porosity for heat air to transfer up to the roof space before ventilate out of the building. So to conclude our project, the design have achieved 3 goals. First, according to the optimization, this form can reduce the building surface temperature equal to 3.3 degrees Celsius different. And second, the structural material, the timber structure can support and become major parts of our project as we want to use the carbon neutral base. And last, the facade create not only the opening for ventilation, but also a self-shading system that could reduce direct solar radiation and provide enough daylight factor for indoor space. And this will be the end of our presentation. So thank you for the team for the great work and everyone for listening.
Thank you.
Thank you, guys.
So group 4 is ready to go.
Yes.
Hi, can you stop screen sharing?
Oh, sorry.
Yeah, thanks.
Okay.
1 second. Hello, my name is Natalie. Together with Sachin and Harsh, we are group number 4. Here is the structure of our presentation. And the first point is manifesto. The city today is lacking the community space. The modern architecture has created a number of single function venues, which are often separated far from each other. Even the so-called multifunctional or mixed-use buildings are really mostly the retail centers with an entertainment component, and they are usually located far from the residence areas. The only areas fully adaptable to all kinds of public activities are parks, but there the climate issues came into the play. Moscow is located in the sharply continental climate zone with an annual temperature difference over 50 degrees, cold winter, hot summer, and frequent rains in the mid-season. Altogether, this calls for the sheltered public space. Another problem specific to Moscow is the defect of the quality public space in the old residential areas in the historical center. There are plenty of world-class museums and theaters, bars and restaurants, but there is no space which would combine various public functions in one building and suit all ages and genders. Site analysis. The site for the community space is located in the historical center of Moscow on the junction of the New Arbat Street and the Boulevard Ring. The boulevard is really a linear park created in the 18th century in the footprint of the medieval fortifications. And the New Arbat is the most radical modernist intervention into the historical context attempted in 1960. The urban void on the corner of the footprint of the historical building demolished in 1994. The wide and straight street cut through the historical development has created an obstacle to the pedestrian circulation and at the same time opened the space to the winds. The park along the boulevards remains one of the favorite walking spaces, but the square created by the crossing with the new street is empty and unused. Another popular pedestrian road is along the New Arbat, connecting the Kremlin with the Old Arbat Street. The urban void on the corner is the footprint, the wide and straight street cut through the historical development has created an obstacle for the pedestrian circulation and at the same time opened the space for the winds. The park along the boulevards remain one of the favorite walking space. Another popular pedestrian road is the connection between New Arbat and Kremlin, and the plot area is about 2,000 square meters. Most of the buildings in the area date back to the beginning of the 20th century. The important feature of the local pedestrian circulation is that there are no connections between the boulevard and the next back street parallel to it, except the Vozdvizhenka Street. The neighborhood features several landmark buildings. The oldest cinema in Moscow, the Prague restaurant, and the constructivist Mostriprom building, once the tallest in Moscow and painted with the murals designed by Rodchenko. There is one K subway interchange across the street and bus stops in 2 minutes walk distance. Before the project site has become an endless construction spot, locals used to be cutting the angle through it, and the facilitation of the pedestrian circulation is an important domain of the community. Design objective. The design objective is to create such a space and all-year indoor destination which would offer the local community all the basic social services, a space for intersection, leisure, and possibly work, provided that the modern telecommunications allow us to work everywhere. We estimate the need of the space for the community center program around 5,800 square meters. The requirements for the building would be accessibility, transparency, friendliness, flexibility, and adaptivity. climatic comfort all over the year, sustainability. And now I'm passing to Sachin.
Hello, everyone. So I want to start by stating that we from the very beginning knew that environmental parameters are very important to us. This is because our climate is very cold. It has cold winters and very harsh sun. And the approach that we took, as you can see in the diagram, was regularly informed by computational tools. And we would always come back to our basic tools like Rhino and look into the simplification of our design. So as we already know, Moscow has a humid continental climate. It experiences the solar gain in winters due to the low angle of sun and is often blocked due to high radiation in summers. We observe through our analysis that the daily temperature is maximum between June and August, which goes to about 30 degree max, and lowest in December to February, which goes to an average of 0 degrees Celsius. The wind analysis showed us that the site is open to winds from all the directions, which is a serious issue in winter and as well as in summers. So we studied psychometric charts for our site, and we observed that passive solar heating and capturing heat gain can aid to improve the comfort by as much as 40%, especially in heating period. Now I'll come to the massing. So based on our environmental studies, we defined 4 major fitness objectives, which were based on environmental analysis. The first one was to reduce the heat loss in the building by minimizing the northern facade. The second one was to reduce the building shadows on the surrounding buildings as per the bylaws of Moscow. The third one was to, in order to create a shaded space for pedestrians, we introduced the fitness objective of, to maximize the ground canopy. And the fourth one was to maximize the flat roof for creating the negative slope for the building and create self-shading that also collects rainwater from the rooftop. So after several attempts, we closely testing with the variations of climatic analysis, we observed that variant 1 worked best in the parameters which we had given.
And here there was also one more point to be noted, that it was important to note that the best options of each fitness objective were studied to define baseline values, and that helped us to gauge the final selections and also prioritize the fitness objectives in relation to each other and the context. Yes. Next, we move on to design elements. Yeah. Sachin will continue.
So I want to talk about the 3 major components in our design. One is the light wells, the skin, and the plaza. So we went forward and we did a daylight analysis on our initial model, which we got through Policy. And after initial daylight studies, we found that our variant, which was our variant 01, from the Policy, it lacks natural light in the center. And in order to tackle this, we introduced 2 more light wells in our building to improve the daylight. The skin. So concluding from our climatic analysis that wind is a huge issue in Moscow, both in the summer and winter period, we decided to wrap our building in a skin of structural timber. By doing so, we not only protect our building from the winds, but also add in to the urban albedo of the city to reduce the heat gain and also the urban heat island effect. So an important aspect of a proposal includes creating a public plaza on the ground and the lower level. It extends as a canopy for protection from rain and snow. So after mapping the pedestrian movement around our site, we ran a few simulations and created a seamless pedestrian movement, crossing in diagonal motion and cutting the urban plaza on lower level into smaller parts. Regarding the simulation, the interest points were determined as per the landmarks and the movement of people was mapped from different orientations. Finally, the circulation routes and directions were defined from the simulation and were further refined manually. We ran a few simulations for winter and some summer winds that we got from our previous environmental analysis. We observed how these winds form a pattern around the building, and what effect do they have on the structure. So these CFD simulations helped us to understand that the average speed of wind around a site, which came out to be around 1 meter per second. And we can see that the variations of wind more closely to our context, which wasn't possible with windrows diagrams using Ladybug. So we went ahead and we tried vertical sections to understand the relation of wind speed and height. After careful observations, we found that our site, which has wind coming from all the directions, has average speed of 1 meter per second. We wanted this data to further inform our ground level perforations on the lower level of canopy, but unfortunately, that is yet to develop because of a very heavy model. So hence, to simplify the lower level, and due to this unorthodox behavior of wind in the climate of Moscow, it made most sense to us to close the timber frames using innovative materials like textile, like in textile facades that could help us to not only protect from wind, but also help in cleaning the air, the smog particles, which is quite a problem in Moscow. So our proposal includes addressing the challenges of designing a building in the cold as well as harsh summer climate of Moscow, protecting from direct sunlight and glare by timber screens, which can be operated as per the need. Also by creating vegetation both on the lower level as well as the upper level. With deciduous plants, we aim to reduce the heat gain in summers and contribute in solving issues like urban heat island effect in the city of Moscow. Now Harsh will take it forward.
Yes, further we try to understand how the structure of the building could be optimized. This is a glimpse of how from our earlier analysis of the winds, the speed and the directions of the winds, how that impacted the facade. And we tried different subdivisions on it, considering both aesthetic and structural implications, and finally arrived at a density that was arrived mainly by the structural analysis, which we'll see further. To optimize the structure, it was first necessary to understand the homogeneity versus the heterogeneity, which part distributes the loads dominantly or is it equally distributed. Since it's a public space which we want to create, the intent was to make the floors lightweight and a continuous shell, thereby making the pores and the facade the major structural system. So thus it was crucial to understand how different elements of the structure work. So this is an overall study to see that. We see that the shell elements which take into account the vertical core, the concrete timber hybrid, and the lower ground concrete shear wall. And it was good to know that the floor load doesn't affect the cores as much as the gravity load. And the shear wall aids majorly in relieving the stress from the cores. The results therefore showed that overall the shell elements work less effectively in load transfer compared to the beam elements. Then we looked into the beam elements in further focus on the facade, like the diagonal timber beam elements on the facade, as well as the light wells, where we saw that they worked much harder to support the overall structure due to basically the vertical loadings. So these studies help us to understand the effectiveness of the timber concrete hybrid over the predominantly concrete structure. Then we did a comparison among the utilization of various elements. The base and the shell concrete elements have the potential to work even more, thereby giving an opportunity to make the structure more timber and much more lightweight. So later we also did some displacement studies of the important elements of the structure that informed us that both the nodal displacements and the bending due to the vertical and lateral loads are within the permissible limits as set by the building code. So finally, these studies helped us to apply on the structure based on the facade also. And the facade study was also important to understand its stability. The deformation, axial, and bending forces were taken into account. It was noticed that it faced high deformations along longer spans and high tension and compression along major wind load directions, and bending due to inadequate support in some locations. So in order for forces to be transferred more evenly to the shear walls below, it required some additional bracing elements. So we then looked into how some further timber trusses with steel cables could be added at these strategic areas that could further enhance and optimize the structure. So this is a render that shows that. Further, we'll look into how the program was developed in the building. Natalie can continue.
The building is designed as a new agora, the multi-level gathering space with the multiple social functions stacked vertically. The lower level is a resistant sheltered semi-outdoor space. It's open from all sides and not artificially heated or cooled, but the projection of the building skirt canopy protects it from the elements and creates a more comfortable microclimate. For the street level, one may climb up the continuous wide open stair combined with a series of amphitheaters, which runs along the facade through all floors up to the roof, or to take an elevator directly to the destination floor. The spiral stair amphitheater space defines the figure of, to the ground relation as an uninterrupted. One may take a continuous walk up and down, the floors becoming the stations placed on the different levels along this journey. Now we'll take a closer look at the architecture. Each floor of the building is designed as an open space around vertical wards. The floors are connected by the wide open stair and the elevators and wrapped into the structural facade skin. The dynamic shape of the wall and the cores are the key players in the drama of spaces and surfaces. The walls deliver the daylight to the middle of the building, which is quite deep. The structural skin is at the same time another opening for the daylight and the protection from the sun radiance, depending on the season, time, and weather conditions and program. The combination of triangles and rhomboids, which form the skin, creates endless variations through the multiplication of turns and angles. The building looks different from any viewpoint, yet its shape is not random, but informed by the site conditions, structural optimization, and outdoor comfort requirements. The dynamic volume creates the new dominant and completely reshape the entire square, which has been staying under design and somewhat unfinished in terms of the overall architectural composition. The building becomes a cornerstone, holding in place everything that has been visually falling apart before. As it usually happens, the well-grounded solutions work well in many senses. The sophisticated shape of the building created through the environmental optimization procedures adds value to the site by opening the views of the landmark buildings around. This is the semi-indoor space under the skirt. That's it. Thank you very much. Let's watch a short movie.
Thank you very much, guys.
Movie?
Just a second, I'll reshare.
Thank you, guys. So group 2 can go.
Can you see my screen?
Yes.
Damn.
Let's go to the next group.
Maybe in the end.
You've done
maybe
a
in the end we'll
video.
show it.
You can definitely add it to the blog post, and it will increase the impact of it. So can we move to group 2?
Sorry about this. It's just we really run out of time, and Angelos is also need to leave in 5 minutes. So we want to see a bit of the last presentation.
Thank you.
Sorry, I think there's a problem with Google server. I don't know if anyone's having. I see you have the same thing on your slides.
Seems that the server is down.
Yeah, I think.
Yeah.
I have the same problem here.
Yeah, we
For
can't
us
access
as well.
the slides.
We can't access the presentation.
Yeah.
At all.
Bad timing.
So it's Google's fault.
It's Google's fault. 100%.
Yeah, it just happened like 5 minutes ago.
Actually, we have the same problem here, yeah.
Oh, yes. So can we probably, sorry, you hear a baby in the background. Can we probably go to have some feedback for the previous 2 groups, and hopefully Google will be back up very soon.
Sounds good.
So who would like to get ahead on this? Maybe we want to hit Angelos before you go.
Yes, sorry about that. So I have a comment about the first. I have to really go in 3 minutes, but maybe the first group can tell me. So I like that you actually did follow the advice of like looking at pressure. First of all, again with both groups, really great to see the environmental simulations. Really like well done. First group, you did like this pressure like kind of like analysis of the wind, like we did the CFD, and you'd have like this pressure analysis on the facade, and you're like basing on that kind of like where you're gonna add openings and where not, if that's correct. Yeah.
Yes.
Yes.
Yeah. But then you have this component that I haven't seen up to now, which is like this kind of like decorative like geometry, which is like controlling, I think, daylight or solar radiation, or is like shading component, right? So there's like wood, let's say it's a differentiating component, right? I'm not sure how well that would perform. For example, like it's a completely different thing when you have something that's open and when you have something that's perforated, right? So maybe what you could do is do like a simple CFD study on one of these components and see how like wind goes through it, and whether it's like really affecting the wind flow, or and then I think also when you like add openings to a building, you need to like see how you change the wind flow, because it's not like straightforward. Well, if there's pressure here, there's pressure there, then the wind will go through. You need to see if your assumption is correct. Yeah, so maybe that's the thing. And I'd like to hear, I really have to go in 2 minutes and I can't really delay that further. The second group, you had this light well, and then you had vegetation on it. I'm not sure exactly how that works. Can you talk a little bit more about that?
We have a thick building. It's around 50 or 40 meters, like the boundary box. And when we made the first calculation, we have a like totally shaded space in the center. And then we put two light wells, two towers, which work more close to the south part, because the third one is the course with the elevators and stairs, and it's more needed for the structural stability. And then run the simulation again, and through these light towers, we provide a light inside. That was the point.
What about the vegetation? There was some vegetation. I think I saw a rendering like that had like some vegetation.
It was a public space on the roof, because it's in this it's historical center, and it's very nice to go up and to observe buildings around. And then we have a lot of rains, and we decided to make a roof garden, small one, not just flowers, and collect this rainwater.
Okay, but there's no trees there.
No, because the construction is not super thick for that.
Okay, cool. Because I thought that I saw trees and they would be like,
no.
I thought I saw some trees and they would interfere with the, the light well wouldn't work if you have shading on top of it. But yeah, like overall, sorry, my mistake. Overall, as well, really great and very thorough, let's say, analysis on both projects. You really like have done a kind of like environmental analysis on all aspects of the building, which is really, really great. I think I congratulate you for that. Both your projects and the previous ones. I'm really happy with what I see in relation to what we've been teaching you. And it's like all of your let's say analysis and your comments on the environmental simulations, they're not just like, we ran the simulation, it looks great. They're actually on point. Yeah, that's my, so I'm just praising our own work essentially here. So I thank Aris and Sarah for that, because I haven't done much. Yeah, but I think great presentations for both. Yeah, I have to go, unfortunately. I'll stick around to just hear Carlos's first comments, and then sorry about the last group. I'll see you tomorrow.
Thank you, Angelos. And thanks for joining and staying with us so far.
So I'm going to jump in. Thanks, Angelos, man. It's quite interesting, all the things that you guys are doing here. I think these two projects that we have seen today, I think you guys have really hit the nail of commercial production for environmental sustainability, development of diagrams and everything, because the way we normally present things when we have to develop projects is kind of similar to the way you guys did it now for these two specific projects. So I like the fact that you also talk about, for the Moscow project right now, I saw a very interesting diagram at the beginning that you took into account the fact that when you do an analysis, it's not that you submit the analysis and you run away with that thing. That's my building, that's my analysis. You highlight the fact that you're doing a process of optimization after the first round of analysis. That is something that we really encourage architectural teams in big offices to do. Not everybody does the same way, but I think like that's the main thing, is that you do an analysis on a first initial geometry. Later on, you do the optimization. That means that you make adjustments, so your building work better on the second iteration of analysis. So it's always kind of like a two-step process, and I like the fact that you kind of mentioned that that was the idea from the beginning. So I'm sure that all the teams here have been doing their own analysis and checking things in order to optimize and improve the building at the end. But that's normally the steps that are kind of in the commercial thinking of the buildings. Also, I think that it's quite interesting, but I missed something related to renewables, guys. You consider that thing, because I think I didn't hear any of the press talking about implementation of renewables, so the energy comes from something that is not fossil fuel related. I think it's something that you should guys look in the future, because you're like already created the inception of having a great kind of master on sustainability on its own. So I feel like that would be, besides the fact that you're doing only focus on, or most focus on environmental simulation, if you put everything on the frame, that should be something that should be included, like how you integrate, or how do you optimize the building shape, for example, for solar gain, or for solar panels, let's say, for example, one of them. Because you are focusing a lot on solar, I was thinking that would be interesting to make this comment. But also, now that you're working with lots of CFD and wind flow, make also like assumptions on, or studies on where you can place wind turbines or wind generators that are going to give you electricity from the winds, or even how you're storing energy from renewables. That is something very interesting. I was like looking at the Netflix documentary recently about Islands of the Future, and they talk about how to store energy from renewables using water tanks and water reservoirs. So, because energy that's renewable is not always kind of possible to restore. But I feel like, for example, the first thing that you guys worked a lot with pressure on facades for wind to understand where you have the positive, the negative pressure. That's a really interesting observation. I like the fact that you did all these studies. And also, I know the fact that it's really tricky to make simulations with the computing power that we have in a laptop or a small device. It's kind of almost impossible to get a solution. But I don't know, maybe in the future you guys can check with the school, or if you get licenses for this online clouds, CFD simulations. I'm working with a company called SimScale, and they have a really interesting kind of tool, super easy to use, and give you like super high resolution and very quick visualization and computation with this device and with the tools that they're using. So it's something that I will recommend to explore in the future, because that's something that companies look at. If you have like, understanding on CFD, it's great, because then if you have the right tool, it doesn't matter if you're doing it right now what you're doing with a scopper. With the right tools, you can do amazing simulations, quite precise. So congratulations for that, guys. I feel like it's quite impressive that you're putting together all these type of studies. And also, for example, for the Bangkok team as well, I really like the fact that you mentioned passive cooling and reduction of air conditioning, because that's something that when you're talking about passive strategies, the way that you establish your thinking, it was great, because all the diagrams you use are amazing. And that's the inception for having like a building that can work afterwards. Obviously, it doesn't mean that because you do the diagram, the building's going to work itself, like straightforward. But it's really a starting point, and it's the only part that I saw that you guys were doing this type of kind of wind flow analysis or wind flow kind of sketch initially to develop like these studies. But I really look forward to see the evolution of you guys in the future. But I guess this part was really stunning, and I also like the Moscow one. This is again something that I said before for other teams. It's like I missed a little bit of information about the body carbon on the structures and what you're using, the material selection. But anyway, it's kind of like a point that is interesting for future. And I really like the fact that you both work a lot on optimizing shading for such a. I mean, like I think for the Bangkok is a more warm, humid climate. Obviously, Moscow is a different thinking, but Moscow, guys, be careful, because if you're using a building that is fully glazed and you have like shading on top of it, that could be tricky in winter, and you have really low temperatures. So also consider that the heat transmission and the heat losses that you have on the facade could be massive if you have fully glazed a building in Moscow. If you look at the vernacular architecture you guys have there, I'm sure that you will find like very little buildings with massive windows. and most of the buildings will try to emphasize the fact that windows are big, that are big could be a problem if you're losing heat. So don't underestimate the fact of using shading, because if you're using shading in a place and you cannot remove the shading in winter, you're also having problems, you're causing problems. So, I mean, I like the fact that you guys look at the weather, but I feel like you missed that point because it's something that you need to look at carefully, because like heat exchange are really something you need to look at with energy modeling tools. So that's what I encourage you to jump into energy simulation. I feel that if you work on energy, you will realize that the bigger your windows, the more problems you have. No matter if it's like a really hot environment or a really cold environment, the fact of not having insulation in a window is always something that is could be a problem. But anyway, congratulations for what you've done. I think that both projects, I like the emphasis that you did and the studies that you did for environmental. And I feel it has great potential, man, and girls. I feel like lots of companies will look at you guys in general, not only these two projects, but all the ones that we saw before, from a very, very kind of, I mean, it's very interesting that you are doing that thing now, because all the big companies, they will look at your profile now from the point of view of that you know to do environmental engineering rather than only geometry. I think that in the past, only we were looking at architects that were very good at geometry modeling and doing fancy diagrams and everything. But now I think today, the industry has shifted completely to the fact that you need people that really understand both things, like geometry modeling and environmental simulation. And also, if you guys have the plus of understanding more about sustainability, like all the topics of sustainability, you have a great plus to find very, very good opportunities around the world. So congratulations, guys. Well done.
Thank you.
Thank you.
Thank you.
Google is down, guys. It is. I mean, I just hope that, that there's a breaking news from Independent that the working status is down. So I'm actually having issues right now in the office that I work at. We're also having issues. It is unfortunate, but I guess that, I mean, if we can present, I think that we need to maybe find another moment. We need to kind of reconvene about this. Obviously, this is not part of the plan. Yeah. And nobody wants this to happen. It has happened. Everybody's freaking out because it's Google and it's supposed to be working, but it's not. So I think that we have to get back to you about this.
Cool.
And
yeah,
so we can actually make a very quick presentation at some point during the week. Because I don't think that this problem with Google, it will be resolved in the next few minutes. So I guess that with Oana, we will send you a proper email to set up this final presentation, and hopefully we can finish up with you guys. I'm really sorry that this happened.
Yeah.
Wait, that's all right.
It
is what it is.
Very unfortunate, and it's very strange as well. But
yeah, well, okay, Bausa, you said that it's in London. It's working.
Yeah, here it's working. That's weird. I was actually like Googling what you said. It's like, well, Google works, about explaining itself why it's not working. So I don't know.
So yeah, right now for me, precisely, it's saying that it cannot connect. So maybe it's the UK server that it's working properly, and it looks like it's a malware. Probably there's some hackers, guys, that they're.
Use VPN, guys. Maybe you can work it out.
I think our presentations were too good.
Are you trying? You keep trying? Are you still trying to connect?
In Germany,
yeah,
it's
we're
not
still
working.
trying.
Yeah, but the Google is working, but not the Gmail, not Drive, not YouTube.
Yeah, nothing's working.
If anyone can get onto Drive in the next 2 minutes and download the presentation and somehow send it to your colleagues, that would be great. But I'm not sure if that is possible.
Yeah. it's bad also for the upcoming presentations because all of our work are up there now.
So actually, this is a good moment to take a lesson, to learn a lesson from this, and always download our work. And it will also help if you share it on the shared drive. In advance of the presentation, we can download it, and in case any of this happens in the future, we will have it at hand for you to present from. So it's a teachable moment.
Yep.
Yeah. So yeah, my Google is still trying to connect. We cannot rely on technology so much as we thought. All right.
Great. So I will try to find the time, and I will email everyone involved for your very own special presentation, group 2.
Yeah, definitely.
Guys, I think I can show the video on my system. It's a very quick one, if that's okay.
Okay.
Yeah, thank you. Can you see my screen?
Yes.
That's it. Thank you.
Thank you very much.
Thank you. Great. So I think unless there are any other feedback about the last two projects or in general, I think we can close this session of presentations. And of course, I will see all of you tomorrow for the next one. And we are still going to be live. So for our jurors and anyone else who wants to check out the event, we will always share the Facebook link. Unless Facebook server falls down tomorrow.
Qué loco.
So thank you very much. Carlos, I think, is the only guest that's still with us.
Yeah.
Thank you very much for joining us, and I hope the projects you've seen were worth your time. And your comments and feedback is definitely very insightful and makes us all think about the different aspects that probably in this short 10-week period weren't considered.
Nice. It was amazing, guys. Congratulations to everybody, and I'm very happy that you guys are promoting this. So it's going to be very interesting to see the final results in the future. You're late now, guys. Goodbye.
Thank you very much, Carlos, for joining us. It was a pleasure to see you.
Same, Rodrigo. Talk to you soon, man.
All right.
Bye, guys.
Thank you.
Thank you.
Thank you. Bye.
Thank you, guys. Bye, everyone. See you tomorrow.
Thanks.
Bye.
Thanks. Bye.